Welcome everybody to day two. Same rules as yesterday. We have the first 5 minutes, last 5 minutes without questions. I'm gonna ping each time. For the speakers, please use a microphone. Use a camera. For us in the audience, please also use a microphone. We'll put one microphone to the back. We will love having comments from there as well. Otherwise, it feels very disconnected. If people like to come up here, please do. It's a little bit lonely out here.
There's a lot of chair
So
there.
please, maybe some of you can already move to the front. Come on.
Wow.
And
It's okay.
anything else? There's a
Just
total
can't hear
program
it, just
tonight.
because
Start
it's okay.
6:30. If you
Turn it
haven't
on,
already
you're
taken a
fine.
picture, take a picture. Bring cash and
I think credit cards are fine.
credit cards are fine. All right. With that, I would say take it away.
Thanks a lot for coming. Thanks for sitting in on this talk. The paper is joined with SFIR, who might be here.
I'm here.
Are you here? Also? Great for the team and 10 people. So wonderful. So we talk about how minimum wages might affect firms' wage setting power, monopsony, and how that ultimately can be traced and measured markdown. So that's the summary of the paper, and I'll give you 3 versions of that introduction, I guess, in the first 5 minutes. But a quick preamble to take advantage of these unlimited 5 minutes. So what's monopsony? The idea is to grow larger as a firm. You have to pay more, relative wages or something else, non-wage amenities. There's a frictionless benchmark that this doesn't fit into, that it breaks. That a single employer faces like a market level instantly from the perspective of the employer, elastic level supply curve. If you pay less, no one wants to work for you and so forth, you wouldn't pay more, so there's a single wage, I guess. Other departures are might found something that looks like monopsony, search frictions, differentiated jobs, different amenities of commuting costs, mobility costs, switching costs, policy like non-competes. The monopsony idea is then that rather than this market level labor supply curve, every individual employer faces something that looks like a labor supply curve that has a finite elasticity, say theta. And the firms take advantage of the wage setting power just as a monopolist. On the labor demand side, as a buyer, a monopsonist then marks down the wages that are actually paid below the marginal report of labor, and the micro foundation for that wedge for the markdown inherits the level of the finite labor supply elasticity, that goes to infinity, but back to square one of this. Now, this is a graph I take from Caldwell, Dubé, and Naidu in the Journal of Economic Literature. One of the reviews that have recently come out on monopsony, and you just see this increasing interest in monopsony, I guess. That's why it's figure 1 in the paper. Now, as monopsony becomes part of a toolkit or this conceptual framework, it might make sense to also interrogate a little bit empirically, just as maybe we've interrogated the standard kind of strawman model of a perfectly competitive frictionless labor market. Now, what can monopsony account for? Why is it interesting? Because there are all these labor market phenomena that wouldn't be accountable for by boring, fictional, competitive labor market. Like wage opportunity for similar workers, employer wage premium, employers as wage effect, for example, rent sharing if the firm is more productive, wages go up. You can read policy responses through the lens of monopsony. If there's minimum wage, rather than firms cutting employment dramatically, some might increase employment. You have the micro foundation, as I just mentioned, for first order conditions. For the first order condition for labor demand, you can have markdowns, might lead to misallocation. What's the story of monopsony? In a very simple framework, the downward sloping labor demand curve, the marginal revenue product of labor might be downward sloping. There's a finitely elastic labor supply curve that kind of gives you a firm-specific wage schedule. The larger the firm, the more you need to pay, rather than being at this kind of quasi-competitive equilibrium where you pay kind of such that the marginal revenue product equals whatever that wage is depending on the size. Firms perceive that to be, they internalize the wage setting power, that wages actually change as they grow larger. That's a macro foundation for the markdown. What we usually call this is the marginal cost of the factor employment. And you kind of settle in at a size that is distorted, it's smaller than it usually would be. And rather than paying that level of the wage, you kind of pay these workers that you want to hire exactly the minimum that it takes for them to get into the door. The difference between these two is the markdown. So that's kind of the introduction over here. So what do we see these markdowns in the data? You can proxy for the marginal product in the data. You can compare it to the wage. You have to squint a bit because there's so much work heterogeneity. We'll talk about this in the paper. And indeed, if you try to estimate production functions, take out the marginal product, you see that a lot of firms here, we call this markdown psi, pay less than the marginal product of labor. So these are 2 graphs that are the right one. You'll see again later in the talk. It's what as a when an I construct in logs smaller than 0 would be consistent with monopsony and a markdown. but you just see an incredible amount of dispersion. And these markdowns are also, from the perspective of monopsony, on the wrong side of that vertical red line, you seem to overpay all this mismeasurement. Keep that in mind. So what's the paper in 40 seconds? We had an intersection of wage markdowns, monopsony, minimum wages, and I'll talk about wage markdown measurement. That's what we'll talk about today. Monopsony is a key theoretical source of these markdowns. It generates markdowns. In a sense, the markdowns are the essence of monopsony. Minimum wages often we kind of see intersect with monopsony because it helps us explain wage and employment dynamics. That's not what Esther, Ben, and I do. We, in a sense, want to think about the thought experiment. What if you take away wage setting power for firms? Do they get back to that boring first order condition whereby I push the marginal product of labor to a wage and I become a wage taker? That world, provided sufficient labor supply at that level, markdown should disappear. Now, what do we do in the paper? We attempt the first direct test of the empirical question, which is how does the binding minimum wage for some workers, for some firms, affect firms' markdowns? What we're going to have is not the markdowns in the theory, we have the markdowns that the data hand us, so it's measured markdowns that we'll measure the responses of. What we find when we implement that experiment with the data, that thought experiment, we find essentially that markdowns, the measured markdowns, don't move at all. We're trying to read that through a simple monopsony model and see how far we are. Close to that, in a sense, on a scale between 0 and 1, 1 being the Stallman monopsony model, we're much closer to 0. And that raises the question, where did we go wrong? Where did Esther, Ben, and I go wrong? And where did Esther and Ben go wrong here? Maybe it's the theory doesn't apply. Maybe it's that the research design is faulty. And we've been presenting the paper since January. It's a relatively new paper, and it's been incredibly useful to kind of get thoughts of where we might have gone wrong. Okay.
Can you go back to the model of the markdown with the graph?
And it comes 3 times again, but yeah.
Okay.
In various shapes and forms.
I just-
go ahead.
I'm legally obliged to make the following comment. This is one period.
Yeah.
The next period for a higher wage, and then a higher wage, and then a higher wage. So I don't know. There are so many problems with this theory.
Yeah.
It's a nice picture that you can teach undergrads. I don't know where you go from here.
We'll have a model that has time substitutes. It will not have features that make the time substitutes matter. It will be a spot labor market in a sense. If you're a steady state firm, I think if you go to Bernard Mortensen, you can derive something that looks very similar. If you're in steady state, the labor supply curve will be inherited through reservation wages. You can kind of literally derive this from the reservation wages competing with other firms and so forth. So I think if we, as you go through a difference in difference design, this might matter. But what we then do in applied micro spirit, we say, well, does it differ in the long run versus the short run? But you're absolutely right, spot level, but it's nested in a model that does it. Standards. All right. Happy to push on. But I will pick up on this, and this is exactly in the spirit of the presentation, because where do we go wrong? And where does the world go wrong? The left-hand side is the simple form model, still the undergraduate level. The full model will have more features. This just is what we'll now plot on the right-hand side over here. It's like a first labor supply curve reduced from here. We'll have a fuller model later on. Production function that has the diminishing marginal product of labor, or here decreasing returns actually. And here we have the markdown. That's without the minimum wage. Now, of course, what happens with the minimum wage? You take away firms' wage setting power. Take a look at the right-hand side graph. What happens is you introduce a kink where the blue line here, the vertical portion, is the maximum, the minimum wage you have to pay. That's the minimum wage, I guess. You can't pay for all of these firms that used to pay, used to be to the left of A. You can't pay these workers at low wage anymore. So what you do, we'll have a couple of regions over here, but the most intuitive region that we started the paper with is all of these firms who might be heterogeneous here in productivity. There's a departure over here. Sometimes worker types even will be bound by the minimum wage or not. You kind of cross your marginal product curve on that horizontal segment. Markdown disappears. That's kind of this econ 101, the marginal product equals the wage. That's what we are hoping to identify. Now, it will be a bit more complicated even in that model. When you zoom in, I should have zoomed in before. There are a couple of points here that we'll recycle throughout the paper, throughout the talk. This is the normal region that we'd love to identify in the data, the unambiguous region. And that'll be a story of relative slopes, in a sense, how steeply slopes the labor supply curve relative to the later mark curve. But this is the region where the markdowns disappear. There's a region that's a bit more complicated, which is, well, this is our target group over here. Then there's this group where the firm still, or the worker type here, will be bound by the minimum wage. You pay the minimum wage, but in a sense, you run out of labor supply. this is where the labor supply is the minimum wage. You hire everyone that walks into the door. You would love to push the marginal product according to the minimum wage, but you're kind of stuck at that labor supply over here, and you prefer that, of course. So that this equilibrium is the optimal choice to bunch at that situation where the markdowns still shrink compared to the situation without the minimum wage. If I compare these firms before and after, but they don't perfectly become, they don't perfectly disappear. And then we have our clean control group in a sense, where the minimum wage, partial equilibrium doesn't bind, and the markdown should be the same with and without the minimum wage. That's in a sense our research design. These regions, they kind of no markdown situation is featured in all of these models. The question is, how large is that share? Can we identify them in the data? And we'll try to do that. Now, this is a research design summary, but I'm happy to take questions.
A very quick question. Are you, in some models, you could never see firms with zero markdown because they will not exist. Because they can't, they can't cover the cost of hiring. So there's a selection problem, which is the problem. The minimum wage destroys jobs, maybe it doesn't, but so there may be a temporary effect. It's a question of empirical design, but certainly not expect to see that at all just because they're not there.
Yeah.
I think it's not working.
We'll focus on the balance panel of firms. Great, yes. So we will focus on balance panel and then relax that, find similar results, but that's in a kind of applied micro robustness check. Economically, of course, right. And the model that I just advanced, in the background, there might be fixed costs and so forth. Condition of being in the economy and continuing, indeed, your profit maximizing choice is the one where you pay, you hire up until the marginal product equals the minimum wage at least.
Even if you survive, you can shrink. Initial returns.
Exactly. So let me actually go back to the graph over here. Why is there a point?
But then there's less competition for those exits, so it's not clear to me GE how it works. Without the model, right?
So we have a model that looks like a GE model, it looks like a labor market block in a GE model, but it will be partially equilibrium. But shrinking versus growing, I just want to point out the point B is the cutoff to the right of B, firms expand, to the left of B, firms shrink. And that's the story of where your MPL was relative to the minimum wage before. But that's intensive part of margin shrinking. All right, so this is our research design in one slide, and then I'll kind of microphone that and take it to the data with Esther and then yes.
You can postpone the question, but this thing doesn't really work. You can postpone the question, but I like people like Rafael de Melo and so on, they have looked at things, right? There are people for which the minimum wage really binds, but there are also people where the minimum wage doesn't bind. And when you raise the minimum wage for the people below, their wages seem to be going up as well, even though the minimum wage is not actually, right? So it's not difficult to write models that would accommodate this. This would not be the one, right? And I'm trying to understand how we think about these people where we kind of think, they should not be affected, but they are, and so on, and how would that go in there?
So we wanted a perfect answer. Our estimating equation and how we microphone it, there would be room for exactly this general equilibrium effects, that they were treated or not, and then we'll be clear about the assumptions that we made. They'll map into particular stories. It could be spillovers through the wage index in your labor market, and the kind of CS model that we'll have. If some firms increase that, every firm will be atomistic in that model, but maybe if everyone gets minimum wage increase, your employment share will be a function of your wage relative to that index. So we will have spillovers if we were to include that factor even in our model. We're not going to talk about it. We'll have like labor market fixed effects and so forth. It will all be in shares if you want. However, we discussed in the paper, maybe not successfully, this idea, well, suppose your productivity hasn't changed, but market competition, whether it's a Waterton style argument or this kind of CES wage index, relative to which you increase your wage, then even if you're unbound, if anything, that would shrink the markdowns in the control group, because the productivity hasn't changed, but competition needs you to also increase the wage. So your markdowns shrink in the control group. So that's then a kind of testable indication perhaps, or a concern that we can squeeze into the difference and difference model. But you're absolutely right. What we'll do is we'll take the simplest possible model, a spot labor market model, and which has been used, which is frequently used to study these questions, and see how far we can push that. But different models will have different implications, I guess.
So I understand it is being frequently used, but it's so blatantly off the mark because you don't see workers reallocating day to day, different firms, we'll see long-term relationships. I don't have to ask NYU if I'm employed tomorrow morning and the day after.
I agree.
Yeah, it's fine, strong
Who
man.
knew it?
So just like wheels.
Strong, but it can be embedded. I love the work by Berger Hacken of Monty because you can embed it in a general equilibrium framework. You can ask questions such as, what's the role of an equilibrium supply curve? What's the kind of questions that would be harder to ask in other frameworks? And as I mentioned, although it's a conjecture that maybe shouldn't make in this audience, the Berger Watson model can also be reduced to this story, at least at the firm level. But that doesn't mean
That'd be
that
good to know, because
Yeah.
my understanding is that you find evidence against them all.
I would say that
So
maybe our version of the model is wrong, so that would invite the discussion that we're having. Maybe the markdown measures that we use, remember the discussion,
condition
is not conditional on these markdown measures. One way we could have responded to this audience would be on slide 2 or so, or 4, the markdowns, they go into the wrong directions. None of the models that we just discussed would have rated that markdowns the opposite side of the opposite one. Let's just hold up or something like this, but that should not be temporary. Or adjustment frictions might be sometimes to temporary markdowns or markups, but they're pretty stable and later. All right. So I'll disappoint you, or will disappoint you. Esther and will disappoint you. But yeah, all right. So what do we do? Ultimately, we'll derive the simple and empirically executable, reverse engineered, but actually we think quite robust, but it's here in create micro benchmark, not general equilibrium benchmark, for how individual firms measured markdowns that we then measure move with and without the limit bridge. That sounds like a difference in difference firm level panel design. What we'll arrive at, and we'll have to squint a bit, but I'll derive this in detail, will be that the firm level I markdown change will end up being an intuitive product of two terms. The payroll share of exposed workers, and that's an outcome of a production function. And on the right hand side, how far the markdown of these workers, but we'll only have one markdown measure per firm. We'd love to have the markdown measure of the exposed workers. We'll already make a jump. How far those are below 1. The markdown would be below 1 if you already had your MPL be equal to the wage. The minimum wage is not going to do anything. If the firm doesn't have any exposed workers, markdowns shouldn't change. And that's what comes out of the model, that product. And we'll approximate some terms to 0, and that's where general equilibrium effects, for example, come in. This is a very simple equation. If you're an applied microeconomist, change at the firm level, on the right hand side, there's one term. We can call this treatment intensity that invites running a simple continuous treatment difference and difference regression. We do it with firm panel data. That D is what we can measure in the data. How far is your markdown from 1? And what's the payroll share of exposed workers? We'll keep that fixed and then ask before versus after the minimum wage introduction. Minimum wage introduction, where do you see this? Well, actually in Germany, there was a minimum wage that got introduced in 2015. In the low wage sector, that's relevant here. While there's sectoral collective bargaining in Germany, it's optional. So a lot of these terms weren't covered. Those would be monopolists. That's how the literature sometimes treats the entire German labor market, actually. It always be more. But these firms that would be bound by the minimum wage, where didn't have a prior wage constraints, so that's what we studied. So before and after, what we find is that rather than a row of 1, what's row? Well, this is a model equation. This is an empirical equation. Equation in the model, we run this in the data. The model is correct, the row should be equal to 1. Measurement error or model misclassification aside. That row measure is a nice measure, this continuous measure of how close we are to that, admittedly, strawman model. What we find is a row or preferred measure is much closer to 0. If we find a 0.25, but we actually argue that it's largely mean reversion. So we kind of think row equal to 0 is the preferred takeaway of that estimation. And then the question is why, of course, and you've anticipated already that maybe the model has some problems, or maybe the data. So that's kind of the roadmap in a sense. This is the equation that we will derive in the model and then take to the data. It only has 2 right-hand side variables, payroll share of exposed workers, and a markdown measure at the firm level. On the left-hand side, we also need a markdown measure before and after. That's what all we have to do. I now would like to spend a couple of minutes, maybe, because then the empirical implementation will be simple. I've told you what the result is. How do we get there? Because maybe we go wrong there, and some of the model concerns come in on that discussion maybe, or missing equilibrium effects. We can sign those maybe in which price. So there is something that you've kindly not pushed me on, which is what's a markdown. The minimum wage will only affect some workers. Or no firm in Germany, hardly any firm will have all of their workers be exposed to minimum wage. These red marginal point of labor curves that were downward sloping really should be worker types within the firm. And then this payroll share of workers is usually far from 1. It's not 0 or 1, then it would be easy. We could just see do low wage firms have a markdown of 1 afterwards. But no, the production function has heterogeneous workers, some of whom will be bound by the minimum wage. But the data hands us a firm level markdown. That's how we typically measure using production function estimation and proxying for the first order condition, a markdown. It's a firm level markdown. Now we'll, Esther and I call this a composite markdown, and we'll first derive it from a firm level optimization problem where you can view higher workers by type. And then we ask, well, if you were to go to the data and estimate some composite labor types marginal product, what would that look like? And if you were to kind of do this markdown construction in a model of heterogeneous workers at the firm, what would that actually correspond to? And then particular workers that are unproductive and low wage workers, their wage will be now set by the minimum wage, where for others in the firm will be business as usual, or there might be spillovers. And then we're going to just assume that the exposed workers markdowns go towards 1. That's the subscript of it. Then we make assumptions that I'll elaborate on. Yeah.
So microphone. Thank you. So on the previous point, you assume that all workers within the firm have the same markdown?
Yes. You got it. I'm so glad that I said, well, the markdowns of the exposed workers go to 1. But you're absolutely right. Since we don't measure type specific markdowns, we have to make a jump, which I'll be clear about, which is, it's a euphemism, similar markdowns, but it's actually identical markdowns within the firm across worker types. So markdowns are arbitrarily heterogeneous across firms, but we never have a markdown measure at the worker type level in the firm.
You feel like you could have to get the fact at the end, no? It's like high wage workers have the high markdown.
Exactly. So that would be one way how we'll step by step then say, well, how could we recover row 0 with our assumption? The step that we'll be clear about, which is, well, if we have exposed workers markdown at the firm level, that would be great. What we do is we have to assume that they are homogeneous because that's what we see in the data. Heterogeneous across firms, homogeneous within the firm. That could be one way where we go wrong. So what we do is something that's suggestive, which is on the x-axis, you have the share of workers who are exposed to the minimum wage. That's fine. And then we correlate that with a composite markdown. If you thought that, well, if you only have low wage workers, you don't have markdowns to begin with, you would expect there to be an upward sloping line. We see a flat line that's our indirect test. That there doesn't seem to be smoking gun, that a low wage worker, at least with the production function methods that we use and back of the markdown, they don't have any markdowns. Now, if you have a prior that's a bit odd, that might reflect the fact that maybe the way we estimate markdowns is off.
Just another prior, no. Didn't you show that like high wage workers have a fair markdown in some of them, so. Next paper, we'll see.
Thank you for that. I would think that Justin's paper doesn't estimate markdowns the way that we do.
Sure.
And yeah. Because we need a panel data set of markdowns. All right. Now, this is how we think the world works. Yes, because
So I don't quite understand why markets of the exposed workers have to go to 1. They just need to shrink, huh?
So recall the graph. If you're on the vertical segment, they go towards 1, you become a wage taker, you don't run out of labor supply. Indeed, that vertical segment, that pink segment or purple segment, that's where the minimum wage still is finding, but you hire all the workers that are supplied to you at the minimum wage. You would love to hire more, but your labor supply constraint. Now, how we deal with that is, in a sense, here indeed we assume that they go to 1. 1 with the labor demand determinant. How much that is describing the data, you could say, well, maybe it's a wrong assumption. What we do right now, it's not yet in the paper, but it'll be in the slides. We simulate a model that measures key features of the data and permit there to be this impartial markdown adjustment. They will still shrink and see what row we recover then, and it's pretty close to row, but that might depend on the characterization. They will apply super inelastic to the firm, which it might have to be. By the way, there's also a tension if the markdowns are so large and more optimistic, then the world that you're describing would be super important. It's an open question, maybe that's where how the real world works. Now, this is how the labor demand should work at the firm level, absent the minimum wage. Firm I has these arbitrary role types. These are not occupations, these are not skills, it's a job title in a sense. I look at a janitor at Goldman Sachs, that might be a different janitor than at Rolls and so forth. I set there, I hire up into the marginal revenue product of that type, that's a firm level production function, I might have to mark up, and I set that wage potentially. And this is my markdown coming from monopsony. There might be a firm hyphen or dash type specific labor supply statistic, for example. But what we have in the data is something that never recognizes arbitrary heterogeneity and richness. What we do see is a markdown with an industry level production function, and that will be in a sense comparing average wages at the firm with an imputed average marginal product of labor. What we show, and I'll derive this over here, is that that object can be micro-founded. It's not an ad hoc equation over here, as a payroll-weighted average of these markdowns that we'll never measure, but that the model will have. And I'll talk about this now briefly, because I realized in previous presentations I just claimed that. So what we have is these structural markdowns that actually exist. The composite firm level kind of marginal revenue product of labor doesn't make any sense in a sense, right? Because every type has their own marginal product of labor. But the thought experiment that also guides how we estimate production function is to say, what if I scale up all labor types proportionately? That's exactly what production function estimation tries to do, to estimate output elasticities. Have a kind of Higgs neutral shock to TFP or labor demand. You then ask how do inputs and output co-move that identifies the output elasticity. Then this, taking this in a production function, gives us a marginal product. And all of this is exactly what you would want to do if you have a homothetic production function. You want to scale up these inputs proportionately. Now, therefore, we have micro-founded in the bottom left corner this kind of composite marginal revenue product of labor. That's, in a sense, the type-specific marginal revenue product of labor weighted by the employment shares. Now, that's what drives, in response to, say, homothetic Higgs neutral productivity shocks, or TFP shocks, employment and output adjustment, and hence what we do when it comes to production function estimation. The way to estimate markdowns is you pair that with an average wage. Now, what's an average wage? It's the type-specific wage times the employment rates. Now, if you combine these equations and kind of stick this into the composite markdown definition, you get exactly what we have written out over here. So that's, in a sense, the composite markdown and that we estimate in the data. Now, it's a payroll share weighted average of these structural markdowns. Now, useful partitioning.
But before we go there,
Yeah.
can you go back one slide? So I follow you up until two. Two
Yeah.
follows from the model under some assumptions.
Yeah.
But three is just an arbitrary definition.
Right. No, sorry. It's in a sense, what do we estimate in the data? We've estimated the production function that at the firm
Let me ask
level.
you different. I know that MRPN bar I means something under some assumptions.
Yep.
I don't know what zeta I means in the model.
Well, in the model, it doesn't mean anything. However, in the data, how we construct the markdowns is we say, let's say what's the marginal product of labor, what's the average wage, and then this is an empirical object where they should have a hat where we say, how do we construct that?
But it's not like the representative or average, whatever it is,
Correct.
of the firm, within the firm.
Exactly. However, this is the markdown measure that then the data hand to us. If we ask how does output move if we change proportionately all labor inputs, we compare that with the average wage. We've estimated this, production function estimation has estimated this, and then that gap is what we've plotted in these histograms in the beginning. But you're absolutely right.
But it's not an elasticity of any relevant supply.
This is a reduced form object that we've now mapped into the structural object because that psi is what the data hand to us. You're absolutely right, and I think Esther and I were spending a lot of time deriving this because we realized what would even be the prediction for psi. The psi doesn't show up. However, if you then stick into this equation, the structural equations, we get exactly this. So this reduced form object that we drew back out of the data, or the list objects in the data, should be thought of these economic terms on the right hand side. It's a weighted average. Can you give me 1 second? Because now we can partition it. We're almost done into two types. Any partitioning works. The partitioning that we will implement is we're going to split up the payroll into those that are exposed, and then we have the conditional average of their similarly weighted, payroll weighted markdowns, and all of the other workers that are exposed. Now, if Lucas, if the markdowns go to 1 for these workers, if you aren't labor supply constraint, that's a prediction, and we can do something very simple. We can ask in that model, how does this composite markdown that we then also estimate on the panel data change between two arbitrary periods? But the periods that we study is before and after the minimum wage, with and without the minimum wage. These two objects we now make predictions for, which is they look, we have this direct markdown effect. Of course, anything you can get a prime, which is with the minimum wage, post second period in a sense, versus before. But what we'll have is, this is an equation. The blue terms will sweep below the rug and will tell you exactly which assumption we make to only have this direct markdown effect that we can easily take to the data. And this is where all of your measurement concerns come in, equilibrium effects come in, spillovers within the firm. What if I have to raise wages for everyone? That would be that the markdowns for the non-exposed workers within the firm would also move. They would, for example, here amplify the prediction vis-a-vis what we have in here. But if they're general equilibrium effects, they could go, depending on the model, in other directions. So this is why I was saying this slide, in a sense, as Claude would say, this is where the economics sits. I guess that's a telltale saying over, right? But this is really where we can have these debates, and then we can be clear about, although this is a reduced form equation in the end, where particular concerns would enter, because this is right now an accounting equation that is structurally microfounded. Now, with these assumptions that I just spelled out, no spillover effects, stable payroll shares, actually, if anything, the payroll shares of the exposed workers should go up because the wage goes up. You might want to even expand having these workers, so they would actually underestimate this. This is, in a sense, the percent prediction that we have. We take it in logs, and this is how we get to this equilibrium prediction. This is also why this is, I think, a good slide to have a debate about where we go wrong, because a lot of the concerns, missing things would show up over here. For example, Luca's concern, what if the markdowns don't go to 1 for the exposed workers? In our model, that would be because your labor supply constrained in a sense. That would mean, well, I shouldn't have stuck in 1 over here, and we can price that in a sense. And in the model, we'll run this with labor supply constraints, for example, and estimate that equation in the model and see how close that row is with that concern. But we haven't done a slew of alternative models, of course. But in principle, this would be the laboratory for that. Philip, sorry,
Yeah, my question comes across really boring after seeing all the things that I could ask about this slide here. It was actually a question about the slide before. When you say that this thing is homothetic, right? Usually I scale up all the things by the same shares, but now they have different elasticities and so on and so forth. Would I still blow them up by the same shares after this change, right? You got a question about margin product.
Yeah. So that's, I think, where production function estimation, analysis of monopsony, and I'm not an expert in production function estimation, good at attention. The production function estimation sets usually assume that you might not have monopsony. We can have some adjustments in a sense where we allow for some market power, but I think you're completely right that the assumption that we have that you scale up homothetically in response to the same TFP should, in a sense, would be violated with adjustment cost, first of all, or with monopsony. It shows up as an adjustment cost because the factor that's inelastically supplied, even if there's a TFP shock, there's a total factor productivity shock or demand shock, you would, in a sense, scale up more the flexible inputs. Matthias Mertens and I have looked into this 13 intermediate inputs versus labor. You really see firms that they kind of scale up and grow in response to shocks through intermediate inputs rather than through labor. You're right, but that's how production function estimation, I think, there's assumptions that we are better. I think there's be some.
It's an agnostic approach, so it's like you don't want to take a stand on a specific market competition, and you can take this just as a benchmark.
I just thought with a homostaticity would buy you what you wanted to get, and it sounds like it only does it under very specific conditions. Okay, but let's talk about it later. I get the answer.
Homostaticity, in a sense, I think it would be hard for us to have a model where monopsony is embedded into the production function estimation stage, in a sense, but yeah, it might reflect my hypothesis in summarizing this. All right, so this is our estimating equation, and there's some ways, as I mentioned, like the payroll. This is, I think it's a skip. The payroll should actually go up, so we might underestimate these predictions. So in the paper, it looks as if we have kind of a Rebecca Heckman-Monkey style GE labor supply block, but really, this is partly a proof. It's just the firm. That's a micro foundation. We'll use this also for the production function estimation, there's capital labor and so forth. But it's the boring way to it. The time substitutes in a sense because there are no adjustment costs in capital, nor in labor, nor in intermediate inputs. This is just how to micro fund in a sense the type specific employment, this recurring framework in the background. It kind of gives us the full model of this with heterogeneity importantly, and heterogeneous markdowns, but we have the assumption that the markdowns are homogeneous within the firm. We also, as I mentioned, have kind of a labor supply constraint, whereby the employment that you land at, in a sense, has to be weekly below the labor supply at whatever wage you pick. If that's the minimum wage, you're at the minimum at that kind of vertical component, and you might be rationed by labor supply, in which case you see here, so that's not yet on the paper, these partial markdowns that Lucas, for example, was asking. You might have a different theory in mind. That's our way to, in a sense, of these partial markdown adjustments, and that's what we then simulate. Let me just summarize. If you're much more likely to run out of labor supply if the labor demand elasticity of these exposed types is very high. In the model, the substitution of elasticity between worker types guides how much you want to expand, for example, the janitors and ultimately replace the CEO in a sense. This is here with the minimum wage workers, because you now don't have the markdown anymore. On the x-axis here, we have the substitution analysis of worker types that guides how flat the marginal product curve is. The flatter that is, the more you land, the more likely you are to land at that rational labor supply curve. We then run the model on the simulated model data that matches some key features of the German data, and of the same equation, we can recover a rho of around 1. And then as we make these workers super substitutable, then rho starts to shrink but stays relatively high. And that's one innovation. It might be different with different versions. We're still exploring this because we have these rationing shares, which share of employment is rationed at that vertical component. That's really driving the decline in rho. In our model, it's the only way for this to do it. If you ignore the rationing constraint, which we implicitly have done, we kind of stay in the green line here at the rho of equal to 1. And what we also do is we shrink it to zoom into shrinking firms where the labor supply constraint is less likely to be binding. Yes.
So you've been talking about estimating the production function. You're assuming Cobb-Douglas. I guess what you're after is the marginal revenue cost of labor or some other factor. You see changes in value added, you see changes in the inputs, and you get a direct measure, but maybe only for a specific range. So the Cobb-Douglas is giving you the functional form that lets you fill in the gaps. Is that the idea?
So the assessors, just mentioned, so we do, we estimate production functions that are Cobb-Douglas in the end. We also do transfer, which kind of gives you output elasticities that are a bit firm specific, but really estimates an industry specific functional form, and then the input mix that the firm has gives you predictions for what the local output elasticity might look like. I think what you're saying is correct. Ultimately, we estimate output elasticities for production functions at an industry level, then stick the input mix in a sense into the firm level input, so the production function into the firm level IT input levels. But actually, it's much simpler. What we need is an output elasticity for labor and for intermediate inputs. Markups cancel out. I'll show you in a second. But you're absolutely right. It's Cobb-Douglas or transfer, and that's where we might go wrong. And there's measurement error. And Joachim, I think you have a paper that I think like large firms have different output elasticities and small firms within the industry. You might kind of go wrong by imposing a homogeneous production function on all firms within the industry. What's our data? It's in Germany. The initial minimum wage is 850. I'll describe the data in a couple of slides, but I'll just show you here the time series of the minimum wage introduction. This is 0, because no one got paid €0 in Germany. 850. The gray area is our sample cube for the difference and difference design. The minimum wage is binding here. That's in the structure of earnings survey. We don't have hourly wage data after 2014. We don't need it. But this is in a different data set. Indeed, no one is paid below the minimum wage. This is the log of the minimum wage, the wage that you're actually getting paid divided by the minimum wage. And Niklas, I think I saw this from your Brazil paper. It's a nice way to show this. Or we took it. All right.
Do you have any information on hours, just to get a sense whether the Russian at some point binds, when the Russian binds with, this is the only applies to RV workers, right? The minimum wage.
It applies to everyone in principle.
And for the salary worker, you could just say, I don't know, there's constraints on hours.
I think I should know the answer better. I guess the employment gives you kind of a target, gives you a salary, but also the hours that you're supposed to work. And I would share your conjecture that for salaried workers, probably wouldn't bind.
Yeah, for hourly workers, you would expect, based on the theory, that they would put more hours at the very first step.
They would like to supply more hours from the labor supply perspective.
So the firm would like to give them overtime. I mean, they're cheap, and you say work more. Because you want to hire them, they're not there. They say, well, this is 4 hours. I see.
You're right. So
that's what's asking if you have the hours.
That's a great idea. That I've never seen. So in nothing to show we have indivisible labor in the sense. It's true that if you're rationed at the extensive margin, you should go up just like the police in San Francisco, you should go up the intensive margin in a sense. And I haven't seen anyone look into that prediction. That sounds nice. If the hours margin is flexible, but I guess you're right, I should want to expand at a constant wage at the intensive margin. That's interesting. All right, but I think it was making mostly largely being at the extended margin, but it's an interesting aspect. All right, here there's a data slide. I think you should just assume that we have panel data of establishments in Germany, not firms. Most of them are single establishment firms. And we construct the payroll share of exposed workers. We like that. Same thing for the markdowns. I'll talk about markdown estimations in a second. The payroll share is just below your hourly wage say in 2013, assuming that your hourly wage gets stable, because it's typical intent of feature design, ask what your annual earnings are, and you take that payroll share. Worker within the firm. We see all employees within the firm, but only a subset of establishments in Germany. How do we get the markdowns? The markdowns in now you can read this as this composite markdown, that's an ad hoc concept, or what if there's homogeneous labor within the firm? This would be the definition of a markdown. If we know what the marginal revenue quota of labor is, then we know what your wages, this is the markdown equation. We're assuming Douglas, as John was saying, actually that's exactly what we do as a primary design, but then also look at the chancellor, for example. The marginal product of labor is the output elasticity times output divided by employment. That's what would give us the proxy for the marginal product of labor. The wage shows up here. Actually, it turns out to be a story with Douglas of the labor share divided by the output elasticity. That I here is a misnomer. Here it's really estimated at the industry level. Except for a transfer, this is a firm level concept. That's our estimate for the markdown. Getting rid of markups, that could also distort your first order condition. We do by following the literature to do the same thing for intermediate inputs. And there you can back out the markup. Proxy for that. And essentially the markdown here in that literature would be a ratio of cost shares for labor with intermediate inputs divided by the output elasticities. All right, so that's what we run with. So the check here that I promised, this is just what does the German labor market look like in 2013. X-axis is payroll share exposed. It's a cross-sectional graph. Y-axis is a labor, is a markdown. It's flat. Doesn't seem to be the case, but we have no markdown for firms that are low-wage firms. So that's our indirect test, but I share your intuition that maybe that's surprising, or one would love to do more, except that we don't have these empirical markdown measures. We've met the top graph over here, top left corner graph before. It's just a markdown distribution and the CDF. And these are just spelling out a bit what the dispersion looks like and where it comes from. If you go into the German data and you just ask how the markdowns evolved into the reform, 2011, 2013, 2016, you couldn't tell anything, of course. This is just raw data in the data, with the firm level data that we have. But whose markdowns should move for our model makes it clear. It should be those firms who have a lot of low-wage workers. Tracking firms here, say sorting them in 2011, by their markdown level and splitting them into quintiles. So this line over here, the bottom quintile would be the high markdown firms that are far from being competitive on labor demand. And if you track them into 2015 and you don't see any change, you don't see that for any of these tight quintiles of employment. But that's not the right measure, right? Because maybe they don't have low-wage work, they are untreated. It's just a markdown. Maybe they're all, as Martin would have suggested, and concentrated on high-wage firms. So here we sort you into quintiles by treatment intensity, which is a product of payroll share and the markdown. All of this is lagged. We sort you into 2011, and then check these firms, which happen to be also, they have negative log markdowns, the highest treatment intensity firm, and you don't see anything over here. But how much should they have moved? This is just reduced form. That's why Esther and I implement this kind of regression specification, where the row really quantifies how much these markdowns should have. And that invites here kind of a continuous treatment intensity difference and difference design. We estimated with a firm fixed effect, and it's log markdowns as the outcome variable, the treatment intensity, which is predicted markdown chains with the minimum wage at the firm level, which is 2013 or 2011, for example, markdowns and payroll share. Then we estimate the row before and after, or year by year actually. Now here's what we estimate. The Morphy model would have predicted a row of 1.
Then it would have been helpful, helpful to me to see your very granular data, like one firm that is, 70% of its workers are paid below, or 100% are below the minimum wage, and then minimum wage goes up, and your measure of markup, and we look at the ingredients of the measure of markups, doesn't seem to change. And then we can, dissect one special case.
Yeah. So in a sense, tracking individual firm, you just get noise, but I see the case study spirit in a sense, the quintiles were supposed to deliver that in a sense where we say, let's now run together firms, the 20 to bottom 25% of firms to smartphone should have moved in a sense. But you're right, we could do more. What about it? I take 2 minutes to quickly summarize what we do find, and then we revisit the alternative method, because this is really just a version of kind of
question.
Yeah.
So I've never understood. So if you had an optimistic model,
Yeah.
simulate some data, and then run the production function estimation on that simulated data, would you get the actual markdowns in the model?
So what we do is we have a simulated panel data set of firms and match key moments with markdown distribution, the Piaget exposed distribution, and then run the regression in that model. And that row we recover one, except if we go into Lucas territory, which is well, we run out of label supply because this work is constitutable, and then the row declines. That was a simulated model graph that I had shown before. So for the realistic range, at least for the calibration that we have, we recover the row close to one for exactly that. And that model features things that we in the data can't track, which is Piaget adjustment, or the labor supply you're running out. So that's exactly, sorry to have been unclear about that. So I'll probably also be a little bit unclear about this because this is a row over time. That's row by time period. Minimum wage gets introduced in 2015. The row should go towards one, or should be equal to one at least. What do we see in the data? Well, it moves towards one, but I'll hopefully convince you that that's largely mean regression. That's for all firms. We also, the blue line here is our preferred sample, but it's endogenous here, of firms that have monopsonistic markdowns. 5 minutes left, but I'll hopefully finish before. We could say will be a quarter towards the benchmark. However, recall here we sort firms by the 2013 Piaget exposed. That's probably pretty stable, but also markdowns. Markdowns are jump around, they might be mismeasured. This is just a situation where the markdown was very far from one and now it goes towards one. That's the usual concern, mean reversion here. And indeed, we see that in 2014 already things adjust. So what we do is we do something that's a bit ad hoc, the first stepping stone. We do like a pre-trend adjustment where you fit a trend to the peak period, pre-period, extrapolate it, and then subtract it from the coefficients. You get something that's much closer to zero. And we have a lot of robustness checks that I mentioned before. Within one row would be the prediction. We get something that's much closer to zero. But our pre-analysis plan was a bit to start by sorting first by 2013. That's why we showed first. Retrospectively, I guess, we should have said, well, let's not sort them right before the reform, according to markdowns. Let's sort them by something that's early. Then we avoid mean reversion. The period between 2012 and 13 and 14 will actually be a placebo test. So when Esteban and I then sort to the same sorting and the same research design, but sort you by your 2011 product of Piaget exposed and in 2011 markdowns, and then see how these evolve, you'll see exactly that this is just mean reversion. Markdowns would have gone up anyway. And there's no incremental effect on the measured markdowns from the perspective of the model when the reform actually kicks in. If you kind of try to take out this mean reversion by doing another pre-trend correction, that's ad hoc. It's a statistical correction. If you squint it a bit, you kind of get to that zero coefficient plot that in a sense is our preferred number, which raises a puzzle in a sense. Once you do the pre-trend correction, no matter how we estimate and for which subsample, the measured markdowns don't seem to evolve at all, as the Strawman model would have at least predicted. In fact, they don't move at all in reduced form. Maybe we don't have power, but they don't seem to have moved as our model would have predicted. Although, in Lucas, at least in the model, the simulated model, even with labor supply constraints, at least for our calibration, they should have. And if we try to rule that out as well, something we do in the data, which we actually did before, which is in the paper. Do we have firms that, in a sense, we have exposed firms? There could be a combination of these fashion firms and the firms that are our clean-cut sample. We can never really separate these unless we ask firms, do you feel labor supply constraint? We try that to look at firms that seem to have vacancies that grow a lot, or firms that say, yes, we have labor shortages, but that's maybe not so credible. What we can do is we can zoom into the unambiguous subset of firms that shrink. They should say their employment should be determined along the labor market curve. So we do something where we say, well, let's now see which firms shrink into the reform, maybe because of the reform or maybe because of product demand shocks or whatever. They should not be labor supply constrained, or less likely to be labor supply constrained. We run this in the data, and identifying these firms whose employment shrinks between post and pre, we find exactly the same zero result. And there the story of labor supply constraint seems less plausible and suggested, less plausible to us. So where does it leave us? At that awkward intersection of that Venn diagram? We don't find, at least for the model that we write down, that the data accord with what the simple monopsony model would have predicted. Closer to zero than one, weight on the model. So what's a weak link? Let me maybe end with that in a sense. We could just say that these markdown measures don't capture markdowns. Or they capture markdowns, but they measure labor market distortions that are not explained by the monopsony model as we have written it down. That would mean that the gap from one in a neoclassical measurement makes sense in a sense. The structural prediction is off in a sense. What we measure doesn't actually, with only a fraction of the markdown measures, reflect the model that we write down. With that interpretation, we would have to walk away and say the row gap from one, since it's 0 or 5% rather than 100%, would mean that 95% of these macro measures don't reflect the monopsony model as we write it down. What about the second interpretation? Maybe these macro measures are not triggered by other models, they aren't structural, they are triggered by more rich models as the one that Guido had described, but maybe they're just mismeasured because output elasticity is a mismeasure. Or any other noise that we have, assumptions that we make. But then you would also have to draw the conclusion, the row bias from 1, given that it's essentially 100%, would mean that all that Markov dispersion is noise. So you have to, whenever you see a histogram like this, you might need to say, at least for the low wage labor market, it's nearly 100% noise. And the supply constraints we've discussed more than you probably would have liked. So we feel that that might not be the full story at least. Or maybe the monopsony model doesn't describe the segment of the labor market, the low wage market, labor market in Germany that we studied. And
Yeah. See what happens to production if this is consistent.
I don't know. We didn't, I mean, we done this with the guys. They don't have this.
Am I supposed to stand here?
I think that would be great.
Okay,
I think you can do.
I'm not gonna,
The only thing you have to do is if you,
I'm
yeah,
gonna steal back the microphone. We need one more. So that people can.
if you want to move around,
Push it
just
up.
make sure you have a microphone.
okay, well, I have the pointer, so that should be good enough. Okay, hi everyone, my name is Justin Blesch. This is work with Bearda Larson. Oh, or you want to do an intro? Oh, it's going. All right. This is work with Bearda Larson, Bloody Tasca. Beard is at Copenhagen Business School. Bloody keeps moving around. So the paper is called Which Workers Earn More Productive Firms, Position-Specific Skills and Individual Worker Hold-Up Power. So the old stylized fact that we want to push against is that all workers earn more at big and productive firms. And historically, big and productive were kind of synonymous, and lots of papers found a similar wage premium from working at these firms. The recent evidence breaks this link between firm size and wages. There's an article by Nick Bloom and co-authors in the US. We find something similar in Denmark, and even a little further is that we find that firms can grow and they don't need to pay higher wages. So in the spirit of pushing back against monopsony models, we find an elastic labor supply curve. So what this paper is about is workers in high wage occupations earn rents at productive, but not necessarily large firms. So here's some data just in Denmark in the cross section. So we order firms by log value added per worker, and then we take the average wage, average log wage of workers in different occupations. So in red, we have managers where you have the steepest slope between wages and productivity. And then the low wage occupations, I'll define these later. We have the flattest slope, and then for workers in the middle of the wage distribution, or occupations in the middle, an intermediate slope. There is a relationship between firm size and wages, but it's really just about small firms. Small firms pay very low wages, but once you're getting to this is log or X before is about 50. So once you get to a firm size of about 50 workers, there's no real benefit to workers as far as wages in working in a large firm. You could throw in fixed effects or look at switchers and you'd get a similar result. Okay, so the question that we want to ask is, why do productive firms, but not necessarily large firms, share rents, if this is rent sharing and not sorting, with some kinds of workers, but not others? And the answer that we want to offer is that different occupations give workers what we call individual hold-up power. So what are the ingredients that go into this? So first is that labor is organized into different tasks. You can think about a job as a bundle of tasks that once those tasks have been put together, you kind of need one person to do them. Second is that people learn skills that are position specific on the job. So if your job is to do the model section, you learn how to do the model by writing the model. And lastly, that failed tasks or people leaving a firm affects output multiplicatively. So here we build on Michael Kramer's 1993 O-ring model. So we're going to have a setting where there's incomplete contracts, or specifically workers have limited commitment, and firms can discourage turnover by paying higher wages. And if losing these experienced workers is more expensive for the productive firms, then those productive firms are going to be differentially incentivized to pay high wages, but only to the workers who actually have the ability to disrupt production. So the example that we like to use for this is, imagine a restaurant, and it has two positions. There's a cook and a waiter, and production's the yontif. So both tasks have to be done, but suppose that the jobs differ in that being a cook takes more time to learn the recipes. So the skills are actually job specific. Whereas perhaps a waiter could be jump in right away. It doesn't have to work at the firm a long time. So even though both jobs are necessary, here only the cook has hold-up power because they can't be replaced right away. And so if this restaurant were to become, say, more popular and they could charge higher prices, the firm would want to raise the pay of the cook because what they can disrupt is now more valuable than before. Whereas the waiter, well, they could be replaced immediately anyway, so the firm doesn't have to share any rents with that waiter. And so that's why we would get productive firms are sharing rents with some workers, but not others. So there's a couple literatures that this relates to. So big ones with firms and wage premia. I think the most interesting comparison is going to be with Stoll's-Weibel. I'm actually still curious about feedback because I'm not feeling 100% about the comparison of the two. We build on some of the empirics are going to be kind of familiar as far as looking at worker deaths and looking at pass-through of productivity to wages. We innovate a little bit there. But just to give you a highlight of, we're going to write down an estimated model with 6 predictions. And I'm not necessarily claiming that this is the only model that can match these 6 stylized facts, but I don't really know that many that can. So first, wages are going to be unrelated to firm size in steady state or in the cross-section. 2, there's going to be heterogeneous rent sharing by productive firms across occupations in steady state. There's going to be heterogeneous pass-through of productivity shocks to wages. The occupations where there's greater pass-through, worker separations are going to be more costly. Occupations where there's greater pass-through also will have the separations are more costly at the productive firms, and because that link is really getting at the mechanism here, because the firms want to avoid that turnover by paying high wages. And the last one is that productive firms are going to have low labor shares. So why do we care about that last one? Is I think one of the ways that we really depart the most from sort of the firms and wages literature is that the labor elasticity or the output elasticity with respect to labor is what's going to determine wages and measured productivity across firms, not TFP. So if you think about a standard Burdett-Mortensen model, higher TFP makes firms want to be bigger, they have higher productivity, and they pay high wages. That's not the mechanism here. It's going to be coming from curvature in the value-added function with respect to labor inputs. Yeah.
Question about the empirics you showed in the beginning about the pass-through clarification. I mean, it could also be that there's work average maybe then somehow with the very productive firms just
of course
the best cooks and the very best.
Yes, that could reflect sorting and it's descriptive and motivational. Yeah. So we're going to look at pass-through of changes in wages for stayers. So we get rid of the selection issue.
This will be complicated. It's a simple story. Size has always been thought as a measure of productivity, not size per se. It's a result of it. Now, is it a simple model where high TFP firms have more current production function, and so they want to pay more on margin, but then at some point they stop at a lower size, and they're still more productive. I mean, without all these O-ring stuff. Like Burdett-Mortensen with differential curvature production functions and differential TFP. Would you give that?
So a high TFP is going to make firms bigger. But when we measure productivity in terms of output per worker, it's going to be a function of labor elasticity. It'll make more sense when we get to the market. Yeah, exactly. The curvature, exactly.
All firms have different productivities, but the same wage, and then different sizes, and then see. It's become you have a lot of other ingredients. It's not clear to me whether that's a simplest model to write together.
Yeah.
Why do you go this way with the holdings?
Well, let's talk. Yeah,
it's also just curvature. They're saying they have.
Because you need turnover costs to depend on inframarginal productivity. It can't just be at the margin, and hopefully that makes sense later.
But you don't measure turnover costs.
Yeah, we do. We're
2, 3, 4, and 5. You're gonna pass through.
We're gonna look at worker deaths. Now it's going to be really noisy, but yes. So okay, and one of the implications that at least I find very interesting is you could ask kind of is hold up power good for workers because it's going to raise an individual worker's wage, but it's actually going to decrease demand for labor. And what we're going to do after we estimate the model, we're going to do a counterfactual where we reduce hold up power in the economy and see what happens. And what we're going to find is if you reduce hold up power for the high wage workers, it actually decreases the skill premium. And if you want to think about technological changes that might make high skill workers more replaceable, I think hopefully that's relevant for today. Okay, so for the model, I want to start with the agents and the production function because it's the most novel part. Workers are ex-ante heterogeneous only in their skill levels. So you can think about this as just college and non-college. That's all as far as we're going to go. Firms, when they produce, they use positions. They create positions at a small cost. We're going to take the limit of this to 0. That cost is kind of a technical thing. And then they use occupations K, and then they draw from different skill groups. So what you can think of this is that managers and professionals draw from the college-educated, cleaning occupations draw from non-college, and that's it. for a given worker in a given job or a given position, they can have two potential states. They could be a senior worker where they have learned their skills that are relevant for the position, or they could be a junior worker where they have not yet. And you can define total number of workers as just the sum in an occupation, as just the sum of senior and junior. So what does the output function look like? We're specifically calling this a value-added function. So the curvature, so these output elasticities, the output elasticity with respect to capital and labor, beta and alpha, are going to sum to less than 1. You could think of that curvature of summing weakly less than 1. Could come from product market power. It could come from physical diminishing returns to scale. It doesn't actually really matter. So this is a value-added function. So one input is the number of workers. So both senior and junior workers add productively in the same way. But then there's the second term. So it's going to be the ratio of senior workers to the number of positions with two separation cost or turnover cost parameters. So this delta, to preview a little bit, it's going to be turnover costs that are in proportion to kind of marginal product or later wages. And then we're going to have this H, which is occupation K specific, which is our holdup power. And it's going to have that same labor elasticity underneath. And to preview, actually, we can do it right now, is that is going to affect turnover costs that are proportionate to output per worker in a kind of slightly indirect way. So maybe hopefully this is getting to your question a little bit. So if you were to lose a senior worker, how much does output fall? Well, you lose the same amount of output as you would by losing a junior. That makes sense. It's coming from here. And then you have these two extra terms. One is multiplied by delta. So that's some fraction of kind of regular marginal product. And then we have some multiplicative term on y over n. Now, the NJK is occupation-specific employment K. Imagine a firm that employs just one occupation. So our occupation share sigma is 1. Then we have y over n. So you can think about delta is adding turnover costs sort of at marginal costs or in proportion to wages. H is going to affect or generate turnover costs that are proportionate to output per worker. This is where inframarginal productivity is going to matter. There's a last term here, S over P. This is just getting at that as you lose more senior workers, each one is sort of a larger share of remaining workers. Yeah.
Two questions. One is when we think about turnover cost, holdup power, we think these are dynamic model. We think of these things as not showing up directly in the production function, but being a byproduct of market structure and whatever market friction might be there. Why did you decide to go this way and putting them straight in the production function?
So you could have hiring costs. So you could have hiring costs that are a function, some proportion of wages and some proportion of output per worker kind of mechanically. But we're actually going to look at worker separations. And I think it maps to the data a little bit more cleanly to think about you lose a worker and you see the value added fall. It doesn't strictly have to be. Yeah.
The second question was, this goes both, the derivative goes both ways. You describe it as losing a worker, but it's also adding a worker. And then how do I interpret delta K when I'm adding a worker?
Delta K?
HK.
Delta K, HK.
H.
Oh, I'm sorry.
It's definitely art. It's just how important that person is. It's kind of a multiplier. So the senior worker has this extra kick, and the bigger is Y over N, the bigger is the kick.
Yes. Yes.
Productivity of seniors.
Right, that depends on the average output, right, of the worker.
That's right.
So if you have a lot of, I think try to capture the cook example or something like that.
That's right. Yeah. So that it's
That's what it's supposed to capture.
that was a good answer. So I'm just going to keep going. Okay, so I'm going to embed this into a model. Now, there's T subscripts everywhere, so it's you might be thinking this is a dynamic model. We're actually going to make it a repeated static model with multiple matching phases per period. Now, yeah.
So, that HK, well, let me answer this. That HK is supposed to be a primitive piece of the production which in equilibrium will give rise to that, as opposed to being hold up power, it's just semantics, right? That is supposed to be a primitive production function, HK.
Yes, yes.
That's supposed to be a parameter of production. In equilibrium, that should give rise to that. It is not a hold up.
Oh, so
It's just a weird
that's right. That by
That's all.
you're right. By itself, it is not hold up power, but in the equilibrium that will. This derivative is true for this production function as you change inputs. But whether or not it actually endows workers with hold up power that allows them to get more higher wages, that's going to be an equilibrium outcome that's a function of basically contracting frictions. Okay. So this is going to be the part where if you don't, oh, yeah.
Future basis. So P and N are different because sometimes I might be below scale in a sense, and P is something that moves sluggishly, and
That's right. In theory, firms, when they lose their senior workers, they could decide to hire a replacement worker or not, and so it and can be less than P. Yeah.
And if I replace P by N, that would be consequential because N is picked every period and P is somewhat like as a fixed cost also. Okay.
Yeah, let's go to the timing. Okay, so the sequence is the beginning of the period. So all workers are going to begin as unemployed. Firms learn their production parameters. Then at the beginning, the first thing that firms can choose is they choose their positions and their capital. So these are going to be fixed then for the rest of the period. It's a sort of putty clay-like feature. And then firms are going to choose a wage for each occupation. Then there's a first round of matching. We're just going to have a Leontief matching function. And workers are going to accept if it's worth doing so. In equilibrium, it will always turn out to be so. Also, it will be an equilibrium result that firms make fewer positions than there are workers. So the outcome with this is that every position will be filled, but there's maybe some workers who are not matched. Okay, after workers have matched in that first round, this is where they learn their position-specific skills. So in the absence of a dynamic model, we kind of need to do it with the timing within a period, is that if you match in the first round, you get good at your job. But these workers have opportunities to quit. And so this is a kind of dynamic monopsony, if you will, setting where firms post wages and can't make counteroffers, and workers get some disutility draw, which they draw from some distribution chi. We're going to calibrate or parameterize it to be Pareto. And they say, okay, if I stay, I get some utility. If I quit, I know I'm going to have an opportunity to search again. With the Pareto function, the number of workers who are then experienced, who actually stick around, those are the senior workers that the firm is going to be able to produce with, and it follows that functional form. And this V here is going to be endogenous. Okay, in the second round of matching, it is again once again Leontief, where there's just the recently quit workers, the workers who were not matched in the first round, and then on the firm side, there's just the positions that are recently became vacant.
So there is no wage for seniors and juniors.
Correct.
You post
Yes.
a wage, then you may be good at it or bad at it. The wage cannot be adjusted based on that. And then there is the moving opportunity.
Yeah. And so you can do it where firms can offer, so workers, the workers matching in the second round take the job as long as wages, at least their unemployment benefit. We actually have the backup slide, but you can do it where for the replacement workers, firms just outside offer match. And what you lose is just everything is not closed form anymore, but qualitatively the model gives the same predictions. Yeah.
Can I ask about the intensive margin of hours adjustment potentially? So suppose we need labor services from senior workers and my cook quits, but I can make everyone else work longer hours. I guess that's not here. So I guess my question is, do you think that's a relevant margin in data, these sort of intensive margins of hours adjustment to account for the fact that maybe I lost the previous worker?
Yes, but this is also why we focus on position-specific skills. So if skills were completely firm-specific, firms could sort of overhire and train enough people, knowing in advance that there's going to be turnover. All of this production function is only going to bite if your coworkers can't totally do your job. Yeah.
just in this, to help you with the roadmap. You had the production function before. It has
Mhm.
two elements. One is I'm productive on the margin. One is there's some kind of average productivity.
Yeah.
Right? What's the difference between me just being extremely productive and therefore I can, right? Or me, right? When I'm senior, I'm extremely productive and that's why you have to pay me a lot. Or as a senior, right, I get all these inframarginal rents. How would I distinguish the two? Why are those then?
Yeah, it's going to come from whether or not separations. Well, so that actually, I think what you just said is this, is that it with just delta, you get a greater productivity of the senior workers, kind of just in some proportion, but it doesn't vary with output per worker. It's sort of all at the margin. Yeah. Yeah, Jason. Or okay, yeah.
I guess going back to the timing of things and how you define it. So when a firm hires a worker, it only hires a junior worker, and then they become senior, is that right?
Nope.
So in that sense, it seems like you have a model of firm-specific human capital, in the sense that you're not allowing someone who gained capital at one firm to switch and stay a senior worker at another. But if you think about the productivity motivation you had driving this, it was almost kind of like a worker fixed effect of, you know, workers are a certain level of productivity, or a firm has got a certain level of productivity. So it seemed like you motivated this with a much broader measure of worker productivity than this firm-specific human capital. You're kind of hard coding just because you can only hire a junior worker and senior guys can't jump across.
Yes. So I want you to think about productivity, what really is sort of measured productivity, and we're not there yet. So I think it'll make more sense if we keep going. Yeah.
My question was on the, if you go back to the production function. So now I'm still surprised by the P showing up in production. How should I interpret?
Let me go through a few more slides, and hopefully this will answer your questions. Okay, so this is the firm's problem. What are firms doing? They're maximizing revenue minus capital costs, minus the wage bill, minus these kind of trivial costs of creating the positions. Subject to the constraints of however many seniors they have left is just the ones that they trained and then retained, and then they can only rehire. So I think this is getting to your question about the trade-offs.
Trained, just to be clear.
I'm sorry, well,
it's a match problem. Some matches are good, some matches are bad.
No, it's, well, Eddie, if you got in early, your match is good. In that you got in early and you learned how to do your job. So by the time production,
but you didn't do anything because
that's yes. Okay, so what is the trade-off going on here? Is that firms, if they want to produce more, to get more workers, they need more positions. But because of this production function, adding more positions in some ways increases more failure points in the production process. So if you think about this, you're writing a paper and we should we have 2 or 3 co-authors, and if we divvy up the task into between 2 people versus 3 people, when we add a 3rd person, there is a chance that we all kind of specialize and then we come back together and something isn't done. So adding more positions adds failure points. And the only way to increase sort of this ratio or the retention rate is to just pay high wages. But high wages makes adding positions costly because you have to pay it to everyone. And in the end, what this looks like is an efficiency wage model. When firms have high separation costs, they're going to want to pay high wages to a limited number of people. Okay, so we're still, yeah. Yep.
Still something about the mechanics of
is the number of people that I hire related to P?
Yeah.
Because it shouldn't.
No, it was there.
I can have.
G less than Q in this.
I can have divide the job in 3 parts, the production in 3 parts, and hire 6 people.
Yes, right. So
and then the 3 suckers are kicked out, and the 3 good ones are kept.
That's right. So this is actually why this is where the position specific skills plus on the job learning bites, is that there are some jobs where you just need one person to do it. I don't know how you all code, But if me and my co-author are trying to work on the same code at the same time, it doesn't work. One of us needs to sit down for a day or two, close it, and then pass it off to the other person. And it's the same principle here is that. Yep.
I hired two people, I give them a week, they figure out which one is good. This is on the journey, on the job learning, but it's not really, because there's no time input. No, I think, yeah.
Okay. All right. What is the equilibrium? It's all these decision variables, such that firms maximize profits, workers maximize utility. Labor markets do not necessarily have to clear here. There will be unemployment in equilibrium. Okay, so here's the expression for optimal wages. Note there's no measured productivity here yet. Everything is just this output elasticity. So as I mentioned before, we're going to take the limit as the cost of posting a vacancy goes, making a position goes to 0. It's really just a technical thing that is not really worth explaining. But what do we have here is that we have these parameters that affect the cost of separations. One is delta, one is alpha, and that one is scaled by the labor elasticity. This is saying that if separation costs are higher, firms want to pay a higher wage. And notice TFP does not show up here. TFP just makes firms want to be bigger, they have more positions, but TFP does not affect wages. So how does changes in alpha affect wages? Well, it's only the workers with hold-up power, where variation in alpha is going to change wages. The sign is negative, where low alpha firms pay high wages. So we still haven't gotten out to productivity, and that's what we're going to do next. So there's a few more results that come out of this model. So one is the marginal productivity of a junior worker in equilibrium is going to be equal to the wage that workers set. Just what's the marginal product of one of these workers, or that's the extra output of getting them. What's the cost? It's the wage. So if firms are optimizing, they're going to set these things equal to each other. Firms are also in the setup going to find it worth it to rehire for all their positions. So every vacated position will get filled with a replacement junior worker. Now, the labor share is just going to be equal to alpha. And how is output per worker varying with alpha? Well, it's going to be negative. Low alpha firms with a lot of curvature are going to have a lot of output relative to the number of workers. So that means when we have variation in alpha, low alpha is going to give you low labor shares, but also high output per worker and high wages, but only for those workers with a high H. So there are other things that could vary output per worker. So for example, the occupational composition could affect how we measure output per worker. The capital elasticity could affect output per worker, but none of those matter for wages. The only parameter that creates co-movement between wages and output per worker is alpha. Yeah.
I don't understand the very first expression. It says firms pay junior workers their marginal product, but you don't know who's a junior and who's a senior when you post a wage. So
when firms are choosing the number of positions and choosing their wage, they fully understand how their problem is going to play out. And so
in the firm post 2 different wages for seniors and juniors.
Not what I post, not with what's here. You can amend the model to do that and it doesn't change the results. It's just not closed form.
So firms hire up, yeah.
Yep. Yeah.
If you double the economy-wide common A,
yeah,
would wages double?
Yes.
So
you
keep saying productivity doesn't affect wages. Can you refine that statement?
Yeah, TFP. So
aggregate, if you double aggregate TFP.
Sorry.
In the entire economy, for every single firm, you just
Yeah.
multiply by 2 A's equals to A.
Firm-specific TFP
There.
does not affect wages. Yes. Yeah.
There might be Jeffrey. The result that naive ALP falls in alpha, is that generically true for any complex production function as well? Is that the -1?
I mean, yeah, in general. So like in a really standard Cobb-Douglas production function, average product is equal to wage over alpha, right? So low alpha leading to high measured output per worker is a pretty general feature of Cobb-Douglas. Yeah, yeah. Okay, so that is that's kind of that first key result is that wages are going to move with output per worker, with measured output per worker, not TFP, measured output per worker, only if this H parameter is 0. So what does that also tell us about, say, delta? Well, delta affects the level of the wage. If you have high turnover costs, but they're all kind of at the margin, firms want to pay them a higher wage, but it doesn't really interact with inframarginal productivity. That's what this dividing the alpha is doing, is that now when you lose a worker, it's the inframarginal productivity that also matters. Okay, so now we can talk about match surplus. And this maybe is what Martin was referring to earlier, I'm not sure. So we can also calculate in the model, how do firms profit changes if they lose a senior worker? So we know in equilibrium what firms are going to want to do is they will replace a senior worker if they lose one with a junior, which is also the same as saying, what is the difference between the marginal product of a senior worker and their wage? And you can scale that by the wage, and it is equal to that. So when I started by saying that delta is separation costs in units of wages, that is quite literally what I meant. And then it's just that separation costs are increasing in this holdup power and decreasing the labor share. So low labor share firms are going to be productive and face higher costs of losing a worker, whereas high alpha firms are going to be low productivity and face lower costs of losing a worker, but only in occupations where this is non-zero. Yeah.
So is the surplus derived only because of the fact that you can post different wages?
No, it's
contract that says when you become senior,
yeah,
you pay this much on that, and it cannot also.
If you allow firms to pay the replacement workers a lower wage, the surplus is smaller, but qualitatively it all moves in the same direction. Okay. Okay. Actually, maybe I have that. There we go. Relaxing equal pay constraint. So the black lines here are if we have the inverse of alpha on the x-axis and the wage for, I forget exactly what these were calibrated to, but the black lines are the wages of managers, middle wage occupations, and low wage occupations. The red lines are if you pay replacement workers their outside option. And you can see the surplus will be lower, so firms don't need to pay as high of a wage, but the relative slopes are all the same. So what we get with that assumption is that it's closed form, but qualitatively it doesn't change much. Okay, I think I want to skip this for now because in interest in time. So we have this pass-through elasticity, and we want to measure something like this in the data. And I told you that this alpha in the model is going to be equal to the labor share. And you surely do not want to run a regression of log wages on log labor share. So if you actually, what regression could you run on model simulated data that would recover this elasticity? Why do we want to do this? Because we want to estimate H and delta. And what we show in the paper is that if you do a regression of changes in worker wages, regress that out on changes in the labor share, and instrument changes in the labor share with longer changes in output per worker, at least for local variation in alpha, you approximate this elasticity. So this is building on a literature of estimating pass-through of permanent productivity shocks. Yoon et al. Is I think the most canonical paper here. And what this strategy of instrumenting wider changes for shorter changes does is it sweeps out measurement error. It sweeps out the effect of transitory shocks. But what's kind of novel in our setting is that this particular IV regression is going to ignore changes in output per worker that could be due to changes in the capital elasticity or changes in occupational composition. So in some sense, this is the kind of the right regression to run for this model. One thing that you, I guess, could be wondering is, usually in these models, we think of alpha as kind of a fundamental parameter. Why would this be moving around over time? And I think in practice, we do see firms change, say, their capital intensity. You can imagine beta goes up and the alpha goes down. You could also imagine maybe their market power changes. And if firms have a sort of less elastic product demand elasticity, then the elasticity of value added with respect to labor inputs is also going to fall. So low alpha could reflect high capital intensity. It could also reflect market power. Okay, so we know how to estimate this elasticity in the data. How do we estimate this match surplus? It's actually not too hard. You just get an exogenous separation and you look at the effect on value added less the wage bill. Yeah.
So I guess alpha could also move around in the data, the labor share can move around in data if there's imperfect substitutability. So it's not Cobb-Douglas, but yeah, it's some CDS or something like that. Would that be kind of valid variation for you? That's outside your model, but
yeah, I think this is a weakness of what we have done so far. We've really only thought about the Cobb-Douglas so far. Yeah. Okay. Okay, so now we have our two moments. We have a pass-through elasticity, and we have turnover costs, and we can look at these, separation costs. We can look at these separation costs at high and low labor share firms. So we actually have three moments and two parameters. Okay, so let's talk about the empirical evidence. So we use data from Denmark. What's really wonderful about the Danish data is that it has occupations and hours. And so we can get some measurement error, but we can get hourly wages and we can also get occupation. Firms have value added, the wage bill, the size, industry, and then we can merge this to the deaths registry in data in Denmark. We're not the first to look at worker deaths, but we use it in a different way. We categorize workers into these three broad occupation groups. So this is the table listing that out. We treat managers on their own. We might think their managers are different in important ways. We group together professionals and technicians. These are the most educated workers. And then we lump together all the other sort of lower to middle wage occupations. Okay. Yeah. I'm sorry?
Have you used any firm level data?
Yeah, we have value added and yeah.
So you can see non-investment. I'm thinking about the alphas we're talking about.
Mm-hmm.
You would expect a big change in alpha if they make a big investment. Because there's, usually big investment comes with automation and tooling kind of things.
I mean,
so
yeah.
Some relationship would validate your procedure. Otherwise,
I see. Yeah.
Maybe it's capturing something about this specification.
Yeah. I mean, as far as I guess if what you're getting at is what is changing alpha over time. I think that the Klein. Yeah.
You see big changes in alpha at firms that point in time are making.
Interesting. Yeah. Yeah.
Yeah.
Yeah. So I think actually patents might be a very good example of where alpha might change, because then you'd have more market power, and then that would change alpha. Okay. Okay. So as far as prediction number 6 in that big table, more productive firms have lower labor shares. That's really straightforward. Okay, and here's our empirical regression, or pass-through regression. Is when we implement this, we're going to look at 3-period changes in worker wages. We'll regress that on 3-period changes in labor share. This will be a semi-elasticity rather than an elasticity, because some of these labor shares are close to 0, and it gets weird when you do logs. And then we're going to instrument those three-year changes in labor share with 7-year changes in log value added per worker. These longer time horizons are helpful for various reasons. If you think measurement error persists more than 1 year, and it helps with precision as well. So the sample that we look at is that it's 2008 to 2019. We restrict to firms that have at least 5 full-time employee equivalents for this period. The workers that we look in the sample are the workers with at least 2 full years of tenure. So that's trying to capture the sort of the S workers here. And then in the regression, we have almost 1 million worker firm year observations.
Quick question.
Yeah.
What is 1 minus the labor share paid for? In a growth model, it's capital.
Yeah, I mean
30%. What is your 1 minus the labor share paid for, and how are you dealing with the fact you don't have capital when you measure it?
So we have capital in the model. So we do, yeah. There.
Okay.
Yeah. Yeah.
Take care. What's the variation? What's varying then when the labor share moves? Is it the profit part or you get T's on the base?
Yeah, exactly. So that's kind of what I'm saying is it doesn't really matter. If the variation, if as alpha moves, it goes to capital or it goes to profits. It doesn't really matter for wages or our estimation.
Go to entry.
I mean, it could, but I don't think that all. And also, the things that we're looking at here are kind of in the cross section for firms. So,
Sandy, zero, X any entry, like.
But the entry cost is zero, right? It goes to zero.
We don't have ex ante entry costs. No, we're
The absolute. Yeah, the occupation cost, the position occupation cost, those entry costs.
no, but I think he's thinking about like if there's rents from product market power, where is those paid for? We're not modeling that, but you could think about that somewhere in the background. Okay. Okay, so these are coefficients for the that regression, the pass-through regression. They should be negative because it's a regression of wages on changes in wages and changes in labor share. So as the labor share goes down and firms become more productive, wages go up. So that's why these are negative. When the labor share falls, manager wages go up by a lot. The pass-through is the lowest for the low-wage occupations, and again, something in the middle, but lower for middle-wage occupations. Okay, then looking at worker deaths. So this is where we have limited precision. Because of the data that we're using, we actually have pretty short sample, particularly relative to work that Antoine Berthaud and his co-authors did. But over this time period, 2008 to 2016, we have 1,300 worker deaths. So Denmark's a small country. Happy for the people of Denmark that not that many workers die. We do a couple things to help with precision here. So just to start, we look at, just the sample. We look at workers who are in the firm for 100 hours, so they working full time, and again, workers with at least 2 years of tenure. So we're trying to get at the separation costs of those experienced workers. We look at smaller firms. Really small firms, a death is a really big shock, which is potentially too influential in our regressions. But for firms over 100 workers, a death is just too small to really detect the effects. So the outcomes that we're going to look at are value added, the wage bill, and then the difference of the two. And then we match each treated firm to 5 control firms on exact industry and size, and value added and wage bill, and exact year in industry, and then minimum square distance difference of these other 3. We matched 3 periods before for some mechanical mean reversion reasons. But on the precision front, we have a continuous treatment intensity. So what we care about is the treatment is going to be bigger for firms if the person who died was making a higher wage. And then we're also going to divide the treatment intensity by firm size, because a death at a small firm is a bigger shock than a death at a large firm. Our outcome variable will also divide by size on the left-hand side. So both left and right have size in the denominator. And that's just our matched event study difference and difference. Yeah.
When is the outcome measured? The day after, a year after?
Yeah.
No, the second question was, there's a bit of a tension in the model. Everybody's paid, junior and seniors are paid the same. Here you're using a particular position to identify. How do you identify seniors in the 2 years of tenure?
2 years, yeah. Okay.
That's just the worker is gone. There's no effect on other workers in the firm. There's no consideration of what happened.
Yeah, the whether or not worker deaths are a good measure of the cost of separations in general is kind of an open question. We tried looking at other kinds of separations, but everything else is just too endogenous. So I think this is the best thing that we have as far as separations that are involuntary from the firm's perspective. Okay, so deaths occur in year 0, so there's a partial treatment in the period 0 year. The units here are in the wages of the deceased worker. And so what we find, so take a manager who would be, say, earning $100,000 or 500,000 kroner. Value added falls by 150,000. So that's kind of a first good sanity check for our model, is that after a worker dies, value added falls by more than their salary. The wage bill falls by almost the amount equal to their salary. And the gap is about half their salary.
This is 2 years after?
2 years after. It very large effects.
I mean, I better hire a replacement.
Yes. Yeah.
Maybe they just outsource, because they couldn't hire, they just outsource some of the tasks that you guys are doing, then if they didn't go down, they didn't go down.
That's right. That's possible. And so what we really care about, and as we showed in a line earlier, we care about the difference. Maybe it's not showing up in value added because it's an intermediate now. Yeah. Okay. So what we're going to.
Yeah, profit or anything that takes care of, intermediate?
Yes, but if I recall, it's noisier, and I should keep moving for the sake of time. So what do we do with for the next graph? We're just going to take the average of these 4 years of the treatment period by occupation, and then we're going to split it by labor share. So here we have that per year, about half of a worker's salary cost when we pool all workers. For managers, it's about equivalent to a full year of their salary. For middle wage occupations, again, something in between. For low wage occupations, smaller, not statistically significant. Then when we split by labor share, and so I'm sorry, this is poorly labeled, but remember that low labor share firms are high productivity. So when a manager dies at a higher productivity firm, measured by labor share less than 80%, the profit losses relative to that worker's salary were a lot bigger. Whereas if the death happened at a low productivity, high labor share firm, the losses were not as big. These are very noisy, and I think this is really kind of suggestive. Just when you have noisy outcomes with 1,300 events divided by 6 groups, power is limited. Okay, so what are we going to do? We're going to solve the model, simulate it, and then get some model simulated moments, and then find the parameters that minimize the distance between our model simulated moments and our empirical results. As far as parameters, I mean, it's Cobb-Douglas, so it's really easy to hit all your internal moments exactly. The only external parameter that we calibrate is gamma, is this quit elasticity. So if you raise your wages by 10%, quits fall by 20%. So what do we get is we end up with numbers that look a lot like those pass-through estimates. Is that for managers, we get an H of about 0.28, for middle wage occupations around 0.08, for low wage occupations around 0.04. It really doesn't like delta. It's really kind of saying that those extra turnover costs are not really doing anything. But what I want to highlight is just how big the effect on wages is. This model is set up to say that managers and workers in middle wage occupations are identical, except for how much hold-up power their job gives them. And what this is saying is, with that parameter, is that managers have 20% higher wages simply because they are in a job where if they were to suddenly leave, it's more disruptive than these middle wage jobs. So that's a really big difference in wages in the first place. So as a closing thought, the exercise I want to ask is, how much does this variation in hold-up power contribute to inequality overall? And so the exercise that we're going to run is a counterfactual where we set this hold-up power equal to what the low-wage workers have for everyone. And not too surprisingly, if you get rid of managers' hold-up power, the wage comes down a lot. This is sort of not good for the people who had those great jobs in the first place. But if you look at the middle wage occupations, they sort of have less hold-up power than before, but their wages go up. And what's going on here is the firm is actually now employing more managers than before. And since there's a different factor of production where the supply increased or the quantity increased, that makes these middle wage workers more productive. And the labor market dried up, which pushes up their wages. So getting rid of this hold-up power sort of benefits the middle wage workers. And it also benefits the low wage workers. Because as there's more sort of these higher types being employed, that pushes up the marginal product for workers at the bottom, and their wages increase. So this is it's a stylized model, but quantitatively, this would say if we got rid of this hold-up power, this would compress the skill premium by 5%, which I think is kind of interesting. And why might we care about this now is that now this is really more forward-looking, but if AI is going to make, say, high-skill workers more easily replaced or less position-specific, it takes me a lot less time to figure out what my co-author's code does. Maybe this is not an exercise too far from reality. Okay, so I'll wrap up here. Punchline is this production function with these complementarities plus position-specific skills gives workers hold-up power, which means that productive firms want to share rents with just them. In the paper, we look at some implications for gender wage gaps, the effect of minimum wages. It's sort of different than what you would get from sort of an opposite model of rent sharing. And I think thinking about technology not just makes workers more substitutable, but actually more despecified, I think is something I'm excited for in the future. So thank you.
Yeah, please keep the microphone on, because when you switch them off, you get this feedback kind of thing. So if you're, just have them on too, so if you make, private comments, everybody will hear.
We also got a message saying that there will be no drink reception out here tonight because they expect rain, but we will have drinks at 6:30 in our announced location, right? The NBR is running this little thing out here for
money.
reasonably priced beers, and that is not happening, but our own thing will happen. We flagged it up. I'll put it at the very end, when we are done, I'll put it up again, at the 6:30.
101 South Street.
All right, with that, and say, Nick, go ahead.
Okay, thanks so much for coming, and thanks for putting my paper on the program. A long literature in economic studies the impact of various labor market policies on job flows and the static allocation of workers across firms. But labor markets, they do more than just allocate a fixed stock of skills across employers. They also shape the experiences that workers accumulate over their careers. This paper shows that this dynamic career channel is just as important as the conventional static allocation channel, and that accounting for it more than doubles the productivity cost of policies that reduce worker flows. I make that argument in 3 steps. First, I use worker level panel data covering 15 advanced countries to document 3 motivating facts. There are large differences across countries in the rate at which workers are hired directly or poached directly from one employer to another without an intervening spell of non-employment. These poaching flows are systematically correlated with various labor market policies, such as the tax rate facing jointly a firm and a worker, and the cost of starting new businesses. Moreover, in high poaching countries, workers experience less wage growth over their careers. Second, to interpret these descriptive patterns in the data, I proceed to develop an equilibrium search model that features firms that differ in 2 dimensions. First, they differ in a conventional dimension, productivity, what I think of as a static dimension. And second, they also differ in a dynamic dimension, how productive those firms are in terms of generating new skills for the worker, what I refer to as their learning environment. That, of course, is motivated by a lot of recent evidence we have of important heterogeneity across firms in a worker skill accumulation. In this model, lower policy wedges raise job creation and increase the probability that a worker gets poached. A higher poaching rate, in turn, leads young workers to sort more into a good learning environment, or what I refer to in short as high learning firms, for 2 reasons. First, mechanically, it is easier for workers to find one of these high learning jobs. And second, it raises the value a young worker attributes to being in one of these high learning jobs relative to a high productivity job. The intuition for that is that a young worker that comes into a high poaching economy expects to later in life be better matched and hence have greater use for their skills. And so those young workers then value more being in a good learning, high learning job when they're young. This force gets further amplified in equilibrium as firms then create more of these high learning jobs. Third, I use a quantitative version of the model to analyze and quantify the impact of various policy wedges on worker careers. I find that lowering policy wedges to go from a typical low poaching country in my sample of 15 countries to a typical high poaching country in my sample generates first static output gains as workers move more into high productive jobs that raises output per worker by 4.6%. But it also has these very important dynamic effects as it leads workers to move more into these high learning jobs. They accumulate more skills. The distribution of skills responds endogenously to these policies, and that raises output per worker by an additional over 7%. So my conclusion from this is that thinking more about the dynamic consequences of these policies is first order. these policies not only affect where workers at a point in time, the job they hold, but also the skills that these workers carry into the future. Okay, so with that, let me jump straight into the analysis. So my starting point are 3 motivating facts that I document using worker level panel data covering 15 advanced countries. A key definition in my data source is the poaching rate. So that's the share of currently employed workers that started working for their current employer at some point in the past 12 months without an intervening spell of non-employment. So these workers made a job-to-job transition. As you can see in this graph, that poaching rate varies substantially across countries, from a little over 4% of workers in France were poached in the past year to over 10% of workers in the US, the UK, and Sweden. These poaching flows are systematically correlated with several labor markets.
That's surely a lot of the age distribution. So you might want to measure for younger workers, 20, 30, something like that.
Yeah. So I have that too, and I should have said here also, I agree with you there. These are not driven by differences in the age composition. I've already adjusted for that in my cross-country comparisons when computing these, so holding the age composition fixed across these countries. But it doesn't actually vary all that much across these advanced countries to drive it much.
Sorry, so these are not the raw data?
These are raw data subject to the adjustment that the age composition is held at is the same across all of these countries. But that's a second order thing. It doesn't vary that much across these advanced countries. Now these policies, these poaching flows, yeah.
You get the same differences if you just did the job-to-job transition rates of individual workers as opposed to counting from the hiring perspective?
Right. I don't know. The data, the way they come, this is the consistent measure I can get out of it. Yeah. I would love to measure directly the monthly thing. We can't. This is the best I can do. Okay, these poaching flows are systematically correlated with several labor market policies, such as in the bottom left panel, the total tax rate facing a match. This is the sum of taxes facing an employer and the worker. As well as in the middle panel, the monetary cost of starting a new firm relative to GNI per capita as measured by the World Bank. And in the bottom right panel, I'm also showing that cost of starting a firm is also negatively correlated with the entry rate of new firms. This is consistent with the view that higher startup costs deter entry. And since we know entrant firms, constitute a large share of poaching in the economy, that shows up on the worker side as a lower poaching rate. Now, of course, these are just simply descriptive correlations here. The point here is just to kind of illustrate some of the factors that I will later quantify in the model.
There's one that is missing that may be important for you. It's important for your story. It would be anything that increases workers' bargaining power and reducing the poaching rate.
Sure.
Because it would offset.
Yep, that's right. So what I can at least tell you is that the patterns that I'll show you in a second for life cycle wage growth, they're more pronounced among high-skilled workers, for instance. So if you're thinking about kind of minimum wages, stuff like that, and maybe boost wages, we would expect a lot of these effects to happen, particularly among less skilled workers. That's not the case. I've also looked across occupations, and these results kind of hold across broad occupation groups. Okay, my final motivating finding is that wages over the life cycle grow more in high poaching countries. I'm illustrating that here is plotting on the y-axis estimated wage growth between age 20 and 29 and 50 and 59 relative to poaching. Ben.
Thanks. On the previous graph, if I were to ask, well, is it the job offer arrival rate? If I were to look at UE transition probability, it might be the same story. Do you know whether it's better or is it the willingness to switch?
It is also showing up in I'm not going to measure the UE because I can't consistently. There's a lot of classifications, but I'll measure the NE rate. And I'll show you that also that is higher in high poaching countries. I'll show you that later.
It might be the same story.
Yep. It is the same story. Yep, that is right. Jason.
Going back to the prior point on poaching, can you show that poaching varies independent of the hiring rate, right? Because the hiring rates vary for the old Oppenheim. Okay.
Yeah. So so the NE rate is also higher in these high poaching countries. The hiring. Very good. Now, of course, an obvious concern with this relationship is that there is something mechanical here. Workers tend to experience wage gains when they switch employer. Is that the entire story? It is not the entire story. The way I draw that conclusion is by exploiting the panel dimension of the data to control directly for whether an individual made a job-to-job transition in the past year. And as you can see from the table, somebody who made a job-to-job transition relative to somebody who looks observationally the same tends to experience some excess wage gains in that year. But even controlling for that, there remains a both economically and statistically significant coefficient on the aggregate poaching rate. A slightly different way of stating that argument is to zero in on job stayers separately. And there we see that even job stayers experience faster wage gains in these high poaching economies.
This is a little bit tricky because it was talking about then you would get it.
So another concern with that is that if you know these theories well, which obviously we do, so maybe you've had some personal experience with this. If you receive an outside job offer, you might be able to use that job offer to bargain up your wage with your existing employer. So even if you ultimately stay, you get higher wage growth. Is that the entire story? I want to argue that also that is not the entire story. And the way I want to try to get at that is leverage the insights from canonical models that highlights that a job loss is a reset of that type of renegotiation capital. So if we zero in on workers that were just re-entered from non-employment, they just had a job loss. If that was the entire story, we shouldn't see that relationship. We do see it. It's a little weaker, so it's consistent with some role for this renegotiation capital that you build up over time, but it's also not the entire story. So let me quickly kind of summarize. Yep, Serdar. Sure. Yep.
Like a bunch of other things.
Yeah.
Do you have any way of telling us, this is mostly about
right. Yeah, that's a good point. I have at least correlated these things with the measures of the progressivity of the tax rate, and nothing stood out there. So that's in some appendix of the paper. They are correlated with the average tax rate, but not much, some measures of the progressivity at least. Yeah.
Yeah, be clear.
Yep.
So going back to the case regression, so I actually, Fabian and I did this for the US for different markets. So the states do respond to the E-rate of people like you.
Yeah.
We did this about 10 years ago.
Yeah.
Now that doesn't say anything about the levels though. So it could be that in some countries the pushing rate is lower, but the level wage is higher because you don't have to start from the lower wage. So regardless is lifetime earnings.
Yeah.
In particular, there's an older issue many 4 years ago about holdups that if you have high turnover, you don't invest in specific human capital, it's certainly bad. And so the reason for these market relations is to offset those inefficiencies.
Yeah.
And so the theory should really be about levels, not growth, to make a statement, not make it growth.
So in terms of levels, what I can also say is it is not the case that workers just start at a lower wage initially and then grow their wage more. So workers.
That's possible with the other things that level. So it's difficult to compare those countries for this reason, right? So it's a counterfactual.
Yeah.
Maybe somebody moves from one country to the other, things like that.
Yeah, I absolutely agree. So all I can say is entry wages when you enter are a little bit higher, but I'm totally with you. Many things vary, and you'll see that later too. The factors that I emphasize will only account for some share of the cross-country differences in income or entry wages. So I'm with you there. I'm not sure exactly what else could be done about it, but yep, Philip.
Can I just the next slide? I just try to follow. These are people that went through non-employment both when they were young and when you are old and trying to see what happened.
No. It is at the point, I'm measuring the wages when they were just re-entered from non-employment. At that point. So somebody's age 55 and just re-entered from non-employment, I'm comparing them to somebody who is 25 and just re-entered from non-employment.
Growth is in their previous job?
Growth, this is just life cycle. Yes, that's right. Yep. So this is their wage at that point in time for people that just re-enter from non-employment. So it's artificial kind of life cycle profiles. Yep.
You're normalizing by GDP per capita or something here?
No, because this is within within a cohort, within a country life cycle wage growth. But Giuseppe is right. When I later want to compare levels, that gets tricky, right? I'll do a PPP adjustment. Yeah. Okay, very good. So to quickly kind of summarize, I've documented these three motivating facts. There are large differences across countries in the poaching rate. The poaching rate is systematically correlated with various labor market policies, such as the tax rate and the cost of starting new firms. And in high poaching countries, workers tend to experience more wage growth over their careers, also among job stayers, and also at the point of re-entry from non-employment. So where I want to go next in the next part of my, the remaining part of my talk is to develop a theory to think about these patterns in the data and use that theory as a laboratory to explore and quantify the impact of various policies on workers' career dynamics. Okay, so the model, click here. The model is set in continuous time, infinite horizon, steady state. Is populated by overlapping generations of workers that enter at some age A0, and they exit at some age cap A. These workers have linear preferences, and they're characterized by their learning ability that I denote by psi A. So that in general varies over the life cycle. I'll estimate later that it tends to decline as workers get older. When a worker switches employer, and that comes a little bit back to Giuseppe's point, I think, before about firm-specific capital, I assume that her log human capital falls by some number epsilon. So that's going to be a parsimonious way for me to capture the notion that some share of a worker's skills are firm-specific and so not portable across employers. And I'll estimate that share epsilon. On the firm side, firms differ in these two attributes that I already talked about in the introduction. They differ in their productivity that I denote by Y, and they differ in their learning environment X. So that a firm that has productivity Y that hires some workers with log human capital H produces output of a unique final good that is the exponential of Y plus the log human capital of the worker. The worker's skills, in turn, grows in that match at a rate that depends on both her own learning ability, psi A, and the learning environment of the firm X. Markets are very standard. Random search, Cobb-Douglas matching, bargaining off the shelf, Postel-Venner-Robin's alternating offers, bargaining protocol with worker bargaining power beta. Guido.
This is, can I think of it as Gregory with a life cycle component?
Absolutely. So it is Gregory actually, which is a beautiful paper, already has a life cycle. I think the main key innovation here is to put it in general equilibrium and think about policies in it. Yeah. So I think that's really the distinguishing factor here. As is well known in this literature, this bargaining protocol delivers bilaterally efficient outcomes. In the interest of space, I'm just going to show you now the joint value of a match that determines all allocations in this economy. So here's the joint value. The first thing I'm going to leverage is the fact that all these values, they scale in the human capital of the worker the way I've set it up. So to simplify the notation and also the solution of the model, I'm going to write the scale joint value of a match, J, between a firm with productivity Y and a worker, productivity Y and learning environment X and a worker of age A. So what's that scale joint value? It has four components. First, you're producing some output in the match. The worker is accumulating some skills in that match. Third, the worker ages and separates to non-employment, either for worker idiosyncratic reasons at some rate delta of A, so that might vary over the life cycle, or because the firm exits exogenously at the rate iota. On top of this, there's also endogenous separation. So there's a boundary condition I'm not showing you here. Whenever the surplus becomes non-positive, you can always separate and become unemployed.
Scalability must include B scaling up with
yes, it does. Yes, that's right. Fourth, a worker sometimes receives an outside job offer. It happens at rate P times phi, where P is the equilibrium job finding rate, and phi is the relative search intensity on the job. An outside job offer is drawn from the recruitment intensity weighted distribution of firms, aka the offer distribution F, over these two attributes of firms, Y tilde and X tilde. Now, if that outside job offer offers a higher value, after accounting for the fact that some share of skills are lost in this transition, relative to staying in the current match, the worker will in equilibrium switch and get a share beta of the differential surplus between these two matches. Let me next illustrate typical worker career dynamics in this model. So I'm plotting in the left-hand side panel the distribution of young workers over these two attributes of firms. On the y-axis, a firm's productivity y, and on the x-axis, a firm's learning environment x. For young, and I'm also illustrating, plotting some kind of indifference curves that highlights the set of jobs that a worker is indifferent between, switching between. So for the diamond area of work, it's a worker in that diamond job, and it's showing what type of jobs she's willing to accept as a job-to-job mover.
Why does the line just not pass through the diamond?
Because you lose some share of skills when you switch. Okay, so what you see there is, young workers, kind of two comments. Young workers, they come in as non-employed, so they're relatively poorly matched, and they try to gradually kind of find a good match in the labor market. Moreover, they value relatively highly a high learning job. Why? Well, first, because I estimate, this is based on the estimated model later, that they have a high learning ability, so they get a lot out of being in one of these jobs. And second, they have a long time remaining in the market to kind of capitalize on these investments that you make when you're young. But as workers then age, their learning ability declines and the time remaining in the market shortens. So workers increasingly try to then move into these high productivity jobs where they can effectively, reap the fruits of what they planted when they were young. So a typical life cycle dynamic for a worker is you start in one of these you try to find one of these high learning jobs when you're young, and then you try to move to one of these high productivity jobs. And the key question really for this paper is how various labor market policies and wedges affect or interfere with these typical career dynamics. Giuseppe.
Very quickly, so there's some distribution of offers down here. So my willingness to accept a job with a high learning rate depends how many jobs are there.
Yeah.
If they're all very good, I don't care.
Absolutely.
About the level.
Yeah.
So this is all predicated on some distribution.
Yes.
The question was, the balance, the relation between X and Y, those kind of things. So
perfect.
I mean, this is all very plausible, but it sounds like workers, supply side, is actually doing better than too, right?
Right. So let me next tell you about the equilibrium. So I'm talking about policies. I need to tell you about the other side of the market.
That's what I'm saying. The policies depend on F.
Yeah.
Which is a good object itself. So I don't know if you make statements about policies that telling us what F is.
Oh, I'm going to tell you how F is determined in a second now. Yeah.
I think you can prove a theorem that the indifference curve flattens.
I'll prove
just because F is age independent.
Yeah.
You're sent both groups.
Yeah.
Right.
That's right. Yeah, that is right. That is right.
I think that's flat as you want.
Sure.
You can prove they're declining, but
yeah. No, that you can show as a little lemma. Yeah.
My question, the correct distribution of X and Y across firms is going to be adoption last week.
That is right. So I'm going to tell you about that just now. So how does that arise in equilibrium? We need to think about the other side to think about policy. So there are incumbent firms in the market. They advertise vacancies subject to a standard isoelastic cost that generates a first order condition that equates the marginal cost of a vacancy on the left-hand side of the top equation to the expected return of keeping a job open. That expected return has two components. At some rate, little q, an open job contacts a prospective hire, and conditional on contacting a worker, there is some return to the firm of that meeting that I denote by big Q. What's that? That has kind of two components. An open job could contact first a non-employed worker, in which case, if there's some surplus from forming the match, it'll be formed, and the hiring firm will get some share 1 minus beta of forming that match. Or you could poach somebody, you could contact somebody who's already employed somewhere else, and you have to try to poach that worker, in which case sometimes the firm will be successful and get a share, again, 1 minus beta of the differential surplus between forming these two matches. The final piece of the model is an entry margin. So prospective entrants can pay an entry cost, CE, in return for a random draw of a bundle YX from the entry distribution gamma. That's going to result in, in an equilibrium with positive entry, which is the case in my estimated model. This has to hold with equality. The cost of entry has to equal exactly the expected return from entry. Pat.
Across countries, are the gammas the same?
Yes, they're going to be the same. Yeah. So the name of the game.
Way to sort that out?
The name of the game that I'm going to play, the way I'm going to try to sort it out, I'll tell you about this. This is a little, anticipatory, but yeah. So I'll tell you exactly what I'll do to try to isolate the particular forces I have in mind. Okay, so next, let me tell you about policy equivalence. So various labor market policies, including, you didn't see this before, tau is just a proportional tax on gross match output, so scales all the values that you saw before. A change in the tax rate tau, or a change in the vacancy cost. I think about that as an incumbent wedge, policies that affect the cost of scaling up existing firms, or a change in the entry cost. I think about that as various wedges affecting the entry margin. They all affect this economy identically up to some weights. Okay, they all affect this economy through a cost composite C. So that conditional on the same change in that cost composite, these various policies have almost the same effect on pretty much all outcomes on the worker side. The only difference is going to be they're going to affect some firm size moments a little differently, and I'm going to use that to separate these two policies. But apart from that, they'll have identical effects on this economy.
But the joint value equation has to be adjusted for the tax rate, right?
Yeah, but it scales it all out. So
Scales it out in what sense?
It's like a reduction in
yes. Yeah, it is a reduction in productivity, so it would just all entirely scale up.
The one issue here is if you have a different tax rate on wages as on capital, because that breaks the transferability of utility and all the bargaining.
Yeah. Yes.
To be.
I'm not. Yeah.
So here, I guess that's the way to interpret that tax on match output.
Yes.
Equal tax rate on capital.
Yeah, that's right. Yep. Very good. Now, how does that change in that cost composite? Again, it could be driven by either of these kind of policy levers. A change, say, a lower cost composite. If you're focusing on a stable equilibrium, it's going to raise poaching, not surprising, it's cheaper to create jobs. And moreover, it's going to lead young workers to sort more, value more a high learning job. I'm illustrating that here in this graph. It's showing how these poaching curves kind of tilt in favor of a high learning relative to high productivity job. The intuition for this result is that young workers, in particular, when they come into the labor market in a high poaching economy, they expect to be better matched later in their careers, and so have greater use for their skills later in their careers. And so they start valuing accumulating skills more when they're young. Now, finally, this force gets amplified in equilibrium as firms then respond and create more of these high learning jobs. You're seeing that also here in this graph. It's plotting the difference in the offer distribution between the high poaching and the low poaching economy, where gray here represents a positive difference. And orange is a negative difference. So you can see how jobs, the offer distribution, shift out of low learning jobs into high learning jobs. John.
I can understand if you start changing the discount rate, would you have something similar because
Yeah.
changing the way that people value sort of things like
Yep.
career?
Absolutely. Yep, you would. Yep. Yeah, and I mean, it comes back to maybe Pat's point too. The name of the game I'll tell you about in just a little bit is I'm gonna try to isolate some particular wedges. They're not gonna go the entire way. So if you thought that maybe some policies influence people's discount rate across countries, that might maybe go a little further in terms of I'm gonna get about 37% of the life cycle wage growth. So there's a lot of additional variation. Yeah, absolutely. Yep.
We can say that the channel works through labor market tightness. Like I make vacancy costs mostly more costly, and so it's the tight labor markets. This is a policy that affects.
This would also affect things identically up to, again, some weights, matching efficiency. Yep.
When you say create more fast learning jobs, is it in the firm's entry decision when they face different gamma y axes and then say, oh, a high learning X in this environment will make more? They must wait when the guy enters. And he pulls a gamma y-x. He's in a different environment. I presume what they turn down and what they carry through differs across the tax environment. It's pretty cool.
Gamma is going to be the same. So you have no control over gamma when you're entering.
It must be turned down once. In a Hoppenheim.
No, there's no fixed cost. Yeah. No. There's no fixed cost of operation here. So once you're in until you exit exogenously. But some of them are going to be inactive, so you're right. So I think about that as on the incumbent margin. Some of them are going to opt to never create any jobs. There's going to be some firms down here that are kind of sitting around until they get kicked out. but they're in some sense inactive. So yeah. Okay, very good. Okay, let's put some numbers to this. So just to kind of quickly preview what I'm going to do is I'm going to calibrate first a range of parameters, to match a hypothetical average fluidity country. Then I'm going to calibrate 4 wedges country by country to match a more limited set of moments. I'll tell you about those in a little bit. And then the way, coming back to Pat's point, the way I'm going to do this, then I'm going to feed in these 4 country-specific wedges, holding all the other parameters fixed at their estimated values. And that's going to be my way to, and I'm going to look at a bunch of untargeted moments in the data versus the model. That's going to be my way of isolating the importance of these particular wedges. Ben.
Is it fair to say there must be one parameter that's, or like one feature that's not affected by taxes, like T or also options? Because I would have thought I can write this as a balanced growth thing.
Yeah.
GDP, nothing's really shifting on market tightness.
Yeah.
The taxes act on output, but not on C. Is that right here? And then you invert it and say.
Yeah, that is right. Yes. Yes, that's right. Yes.
Also affected by the tax, it will be-
Then it would, then it would all scale. I agree. Yes. Yes, you're not changing the cost of creating jobs, but you're changing the benefit of creating those jobs. Yeah. Very good. Okay, so I'm going to impose some kind of, I think, standard assumptions, functional form assumptions. I'm going to have 6 parameters that I'm going to preset, stuff like the discount rate. I'm going to have 4 parameters. So these are the delta of A, the separation rate. I'm going to calibrate that externally to match the EN rate in the data. It's going to leave me with 9 parameters to estimate internally in a fairly standard minimum distance routine. I'm going to target 31 moments in the data. Guido.
It's always unpleasant bundling power in these models. I
Yeah.
guess you put it in the 6 preset.
Yeah, I put it in the 6 preset.
Pick 1/2.
I pick 1/2.
I'm just curious about it. What's the reference for that?
Yeah. Petron,
I'm setting up 10.
Petron and Pizzaridis or something. No, I've tried a little bit. I am completely with you. So I've tried at least the baseline is 0.5. I've tried 0.3. It doesn't change things too much. But I'm with you.
Is there any hope of identifying it country by country?
It's notoriously hard in these models to pin it down well, right? So in principle, I can cook up. I can cook up a moment. People look at stuff like wage growth within a match over time, says something about beta. But from estimating these models at some point in the past, it's just not particularly well informed from that particular moment, even though in principle it should. It typically does. Yeah. Yeah, but there's also going to be this epsilon thing here that so yeah.
The mechanism is, if I understand it, if you're in a favorable tax in another environment, we both pull it, he's in Sweden, I'm in America, and I say there's fewer taxes, so we can pull the exact same YX. I start doing, and I have a high learning one, I do tons of those vacancies.
That's right.
Very little, that's the entire mechanism of.
That's not the entire mechanism.
Of creating the job.
Sure, of creating the job.
And then
Yes.
just moving around.
Yep.
Okay.
Yep, that's right. So these are the moments that I'm going to target. It's over-identified. You shouldn't expect them all to fit the targets perfectly, but it does, I think, a reasonably good job at fitting the targets that we have. These are the moments. Yep.
The one that I thought is the wage growth of the staters.
Yeah.
Because that's the one that, across countries.
Yeah.
It should be only rate of poaching, the salary rate is the same.
Yeah.
But now, if my story is true, that in Japan nobody moves because of the cultural investment of capital.
Yeah.
You will see very different wage profiles from the staters.
Yeah.
So I think that's the one that's really.
Yeah.
Moves because what?
So in Japan, nobody changed job because they're loyal, you can invest in your capital because of that. Because you're
The firm invests in you more.
No, you invest in your firm. You don't, build your firm, that's the story of Japan, right? That's why we get productive.
Yeah.
So that's the good side, of regulation.
Yeah.
And that should be visible in the wage of the state.
Yeah. So I agree with you. That could be one moment I could introduce to maybe also have a relaxed beta, fixed beta assumption. These are the moments that I'm going to target. In the interest, I think some of the mappings between some of the parameters and moments are fairly intuitive. I want to single out 2 parameters and 3 moments. The first is really a critical moment, as I'll come back to, parameter, as I'll come back to in a little bit. It's the dispersion in learning environments across firms. Okay. The key moment that informs that is wage growth at training firms relative to non-training firms in my data. So a really nice and unique feature of these data, cross-country data, it asks detailed questions of workers of informal on-the-job training. One of the questions it asks is, does your employer provide any type of informal on-the-job training? I used that question. About 45% of workers respond yes to that and match it up with the model. I rank firms by X and label a firm as training if it's in the top 45% of employment in terms of X. That's my training firms in the mall. In the data, I observed that a given individual, when she spends time at a training firm, she grows her wage more relative to her own self when she spends time not in a training firm. So this is not driven by selection. Also, these effects on wages are highly persistent. So they stick with the worker even after she's left this particular employer. I'm going to leverage that moment. If that dispersion in wage growth between training and non-training firms is larger, that's going to suggest more dispersion in learning environments across firms.
Not just using wage growth across firms.
Yeah, because I have worker level data. So I can't really do that across countries.
The survey answer to the ID of the employer.
I know if they are a training firm based on the survey data. So that's how I only know a limited set of information on firms, firm size, and this indicator. This is a hypothetical average poaching country that I've constructed. Yeah.
The data is.
If you want to have it, this is Ireland. If you want to have hang your hat on something, this is Ireland in that case. It's in the middle. The second parameter, a set of moments I want to kind of single out, is the correlation between learning environment and productivity. Two set of moments particularly inform that. The first is training by size. In my estimate, all large firms tend to be more productive firms. So if the correlation is very high, you should see a very steep gradient for the share of training firms by size. The other set of moments is training the share of workers at training firms by age. Imagine that the correlation is 1, then the two-dimensional ladder collapses to a one-dimensional ladder. Workers tend to monotonically move up that ladder with age, and so you will see the share of workers at training firms just rise monotonically with age. In the data, it has this hump-shaped behavior, so that also then helps inform that correlation between the two. I estimate that correlation to be high, but not still far below 1. Okay, with that, I'm going to now go to cross-country, little mini calibration. So I'm going to introduce these 4 parameter or kind of policy wedges. They're going to be wedges to relative search intensity on the job fee, a wedge to the tax rate on output, a wedge to the entry margin through the entry cost, and a wedge to the incumbent margin through the vacancy cost.
Understand 2, 3, and 4. What is
1? What is 1? Yeah, so it is quantitatively not that important. It is about kind of a quarter of the effects that you'll see. So it comes back to, I think, Ben's point before. To fully match, let me show you that here. To fully match jointly the NE rate in the bottom right panel and the poaching rate, the vacancy margin isn't enough. You need something more, and that's this. I interpret that it's so not micro-founded, but the idea is the top left panel shows search on the job. I can measure that directly in the data. The service also asks employed workers if they looked for another job in the past 4 weeks, and I see workers, employed workers searching more in these high poaching countries in the top left panel. So I'm going to interpret that as a loose sense as they responding to higher poaching by also searching more. Yeah. Okay, so these are the set of moments that are going to inform those wedges. First, I already told you about search on the job. I should also say it's again over-identified. I'm making sure that the model exactly nails the aggregate poaching rate in a country, and then I'm trading off these 4 moments to these 4 parameters to hit these moments. The labor tax rate I can take directly from the data from the OECD. For the entry wedge, I inform that using the share of employment at large firms. The intuition for this is if it's really expensive to enter, few firms are going to enter. That's going to mean few firms in operation. That means that the firms that are in operation are going to be large. There's going to be a lot of employment at large firms. That informs that margin. And finally, for the wedge to the vacancy margin, that's informed by the NE rate, as we kind of discussed. If it's cheaper for incumbent firms to create jobs, they're going to create more, and the NE rate will be higher.
You want labor tax, or you want labor tax plus weighted by value-added tax?
This is already that. So okay, so this includes all the employer levied taxes on labor. I have not, in principle, I guess you should kind of include a consumption tax or something too, because it's really how you convert output into. I tried that too, and it doesn't actually change these patterns all that much. But here's just the total tax rate on gross output. Okay, good. So then this is what I'm going to do. I'm going to feed in these 4 policy wedges, holding everything else fixed, and I'm going to see what the model predicts for a bunch of untargeted moments vis-a-vis the data. Ben first.
Asking me to smile. So the labor tax one is a policy.
Yeah.
I would have felt that's kind of a bit clownish. You also call it policy wedge, but that's a bit mechanical. Is that fair to say? Like the on-the-job search efficiency, is that
Yeah.
A? And that's should I think of this as being policy, or should I think as being super tightly related to what I see in the data, which is poaching on the job search?
Right.
Policy is a bit.
Comes back to what we talked about with Guido. I'm going to think about this. I kind of need it to fully match the data. If I shut it down, I would shut down about 25% of the effects that you'll see in a second. So we can also run, separately shut down some of these wedges and others. I'm going to think about this loosely, given the evidence you see in the top left panel as workers responding to higher tightness by searching more on the job. Yeah. So it's but it is not microfounded. Yep.
I think you need that to kind of conceptually to differentiate between like Oppenheim, Rogerson stories where, this is all just the hiring margin. By the search by fee mattering,
No.
giving you additional,
No.
this is an additional variation.
No, I that I dispute because Oppenheim and Rogerson doesn't have job-to-job mobility.
That's what I'm saying. It doesn't. But if fee didn't matter in your model, well, that would be telling us that we could just do this for hiring without the coaching channel.
Sure.
So the fact that fee matters.
Yeah.
Differential here and the policy, I think is important.
Yeah, I don't. Again, I've shut it down, and you shut down about 25% of the effects that I'll show you later. So, but we can talk more about that later too. Okay, so I'm going to feed in these 4 policy wedges. This is also in terms of are these reasonable in some sense, these wedges? A little bit hard to match them up with the data, but I'm showing you here kind of relative to the cost of starting a firm as the World Bank measures. They're broadly kind of comparable. Okay, so the main set of results. I'm going to feed in these 4 policy wedges again. I'm going to hold everything else fixed. That's going to be my way of isolating the importance of these 4 policy wedges. The left-hand side panel plots life cycle wage growth in the model and in the data in response again to these 4 policy wedges. As you can see, they account for a lot of the systematically higher wage growth in high poaching countries that we observe. But still, there's a lot of additional variation in the data, so that overall these 4 policy wedges account for 36% of the differences across these 15 advanced countries that I see in life cycle wage growth. I'm not saying these are the only factors. It could be differences in the underlying distribution, etc. Certainly. In terms of output per worker, I'll provide a decomposition of these results on the next slide. In terms of output per worker in the right panel, we observe output per worker PPP adjusted being higher in these high poaching economies. And in response to these kind of 4 policy wedges, the model replicates a lot of that pattern. But as you can see there's even more orthogonal variation in some. So these particular policies account for only a few % of the dispersion in output per worker. So, but by no means do I think these are the only factors behind big income per capita differences. Now let me provide a decomposition of these results. So make things a little bit more concrete now, I'm going to contrast a typical low poaching economy. It has the policy wedges associated with the bottom quartile of firms in terms of, quartile of countries in terms of poaching, and a typical high poaching country that has the policy wedges associated with a top quartile of poaching countries, to make things a little bit more concrete. Moving policy wedges from, again, the low poaching to the high poaching country raises life cycle wage growth by 13.3 log points. That happens partly because match productivity grows more. Workers move up the job ladder more. That raises match productivity over the life cycle by 3.6 log points more in the high poaching versus the low poaching country. Also, the piece rate grows more for 2 reasons. Workers actually start at slightly lower piece rates in the high poaching country as they anticipate getting more outside offers, and they value relatively more those skills that they accumulate when they're young. They're willing to work for a little lower pay, but then they receive more outside job offers and hence grow their wage more over the life cycle. That's 2.9 log points. The single most important factor is greater growth in skills over the life cycle. Human capital accumulation grows by 7.1 log points more in the high poaching relative to the low poaching country. Let me next turn to decomposition also of output per worker. Similar type of picture, output per worker is 12.1 log points more in the high poaching relative to the low poaching country. That is accounted for partly by higher match productivity as workers move up the job ladder more. But again, human capital is the single most important factor. It's up by 7.4 log points in the high poaching country. Giuseppe.
This is the composite wage, so but then you show data on the which one is more important.
Yeah, I have that. Yeah. In words, it's both the entry and the incumbent margin are the most important factors. That was the response to Ben's question. That's about 25% of these effects.
Countries and the high poaching countries are all those people do move within the country.
Sure. Yeah.
Because of institutions and so that would be the one that.
Yeah, so it's about 25% of this.
That's one thing, right? If training for the particular job is important, it wouldn't necessarily show up in wages that much because you can't port it to the next job necessarily. But it would show up in how productive a country is. And I'm worried that high poaching countries make that type of training very unattractive. Right?
So that is
and somehow it doesn't show up in anything that you do. And there seems to be something negative about these very high poaching rates that I don't quite see, and I'm trying to see where it would be in there.
Absolutely. So I agree with you. That was a kind of a traditional narrative back in the days from Japan, for instance. Here it is already there. I have that epsilon. You are not porting all the human capital across employers. I just estimate that to be very small. So that is true. And
sure, the poaching will affect the epsilon.
Sure. Yeah. If it is, sure. Still, I think also this is consistent with Ed Latsier's work, etc., really downplaying the role of firm-specific human capital. So I think, I'm not an outlier in terms of finding a relatively small role for that. Yeah, good. Nobody can interrupt me. So then another way so this already suggests that these dynamic effects are very important. An alternative way to kind of make that case is to contrast the model here with an alternative model that features just exogenously accumulating skills over careers. It has many of the same parameters. I'm targeting essentially the same moments, dropping a few moments as we drop a few parameters. It can hit those moments essentially equally well. And then I feed in exactly the same policies in this alternative model and see what I get. Couple of comments here. First, the response of the equilibrium job finding rate is actually slightly smaller to the exact same policies. It's because the model features a strategic complementarity here. When firms create more jobs, workers move more into these high learning jobs, they build more skills, and that makes them more valuable production partners. Okay. So that's not there in the exogenous case. You get a slightly smaller response of the job finding rate. In terms of life cycle wage growth, it's dramatically smaller. As by construction, you don't have any effect on human capital in this model. And finally, for output per worker rises by only 6 log points in response to the same policy. So this really kind of highlights these dynamic effects are first order here on careers. There's also some evidence supporting this from the data, but I'm going to skip that in the interest of time and end with my final exercise, which is really also trying to argue that my conclusions of important dynamic effects is a data-driven exercise. So the way I want to make that case is that the key moment that informs how heterogeneity across firms in learning environment is wage growth at training relative to non-training firms. So I'm going to contemplate the following hypothetical. Suppose I had gone to the data and I had estimated much smaller differences in wage growth between training and non-training firms. For instance, suppose I'd estimated that to be only about a quarter of what I actually observe in the data. Re-estimate the model to target that augmented moment and all the other moments the same. That's going to lead to, in general, all parameters are going to change, but consistent with the identification logic I gave you before, it's going to mostly load on a lower sigma x, lower dispersion in learning environment. Then feed in exactly the same policies in that alternative calibration of the model and see what that does to, for instance, changes in human capital in response to these policies. That's the right-hand side panel. You can see how the dynamic effects are much smaller, only half of what we get in the baseline economy. So the point here is that, if you want to go to the data and think about how can I get a sense of the sort of dynamic misallocation along this margin, you want to look at kind of heterogeneity across firms in wage growth as a moment, here summarized by this particular moment. Okay, so I am pretty much out of time. So a standard argument in the literature is that policies that reduce worker flows, they generate static mislocation of labor across firms. The point of this paper is that they also affect the experiences that workers accumulate over their careers. And that margin might be just as important as the conventional static margin. And in fact, I find that accounting for it more than doubles the productivity cost associated with policies that reduce worker flows. Thanks so much.
Yeah.
Gonna make us all up, no?
Hopefully, or is the final? Then audio or not?
Yes.
Yeah, no, they're not gonna hear, I mean, they're gonna lose all the.
Just here.
But
Ideally here.
you need to take, otherwise you take a mic and then.
No, I would not stop because sometimes I don't hear the questions.
No, they're-
But here, I'm not
they're
gonna move.
supposed to use the mic, no, they're using the microphone for questions, so they can hear.
All right, I will put this thing here so that people can hear you, and then I'll turn this around. Is this better? Can we still see her?
You can. It's a glare, but it'll work.
But just make sure that this thing will get it. All right, you're all.
Thank you. So this is my work with Patrick and Claire here in the audience and Virgilia. So the premise of this work is that the Diamond Mortensen and Pisaridis framework is an excellent one to account for employment fluctuations of the business cycle. But first generation such models, as I will go over, generate volatility in unemployment through a differential productivity mechanism, whereby, say, in bad time, our productivity falls, but the opportunity cost of employment, the value of no market time, stays constant, so that it becomes relatively less desirable for workers to work in the market and for firms to hire them. This is a pervasive property of these models, as illustrated in an influential piece in 2017 by Lundquist and Sargent. But it turns out, as I'm going to show you, that once these first generation models are made consistent with two observations, the procyclicality of the opportunity cost of employment is documented by Total Rock and Carabarbonis. The opportunity cost of employment is not constant over the cycle. And second, that the opportunity cost of recruiting is workers' time in production, as argued by Sharma in 2010, namely skills with output, then this mechanism is no longer at play, in that productivity shocks lead to no movement on unemployment whatsoever. Namely, the elasticity of market tightness, the job finding rate of unemployment with respect to aggregate productivity is identical to zero. Interestingly, in the same year as Lundquist and Sargent piece, Hall pioneered what we term a second generation of search models, consistent with both Torak, Carabarbonis, and Schreimer's critiques. The idea is simple yet powerful. The incentives to create jobs are essentially driven by the present value of risky surplus flows are those generated by any firm worker match. Hence, variation in discounts, rather than in surplus flows per se, are able to generate large movements in this present value and hence in unemployment. What is key to this novel mechanism is this connection that it builds between movements in unemployment on the one hand and fluctuations in asset prices on the other, which is very much in line with the current finance view that it is discounts rather than dividend and cash flows we were talking yesterday at dinner, what determines the observed level and variation in asset prices. But I'm going to argue, however, that this framework generates unemployment fluctuations through an unrealistic model of discounts, in that almost all variation in whole discount factor, and accordingly an unemployment counterfactor arises from variation in the risk-free rate rather than in the equity premium, which is not in the data. Calling into question this very novel mechanism of discount is a viable theory for business cycles. These shortcomings of first and second generation models then beg the question, what's the way forward? In this paper, we address this question, starting by proposing a baseline model that replaces all these models with discount with a standard one that overcomes the limitations I mentioned. But then we demonstrated three unappealing features nonetheless persist for such a model that is built on discounts alone. First, it leads to large inefficiencies in that the micro-founded bargaining framework that halts borrowers from Hall and Milgram in 2008 leads to an implausible level of foregone profits. It implies the wrong cyclicality of wages. Wages increase in recession and drop in booms. And it runs into an extreme form of the cost and rider puzzle, in that the elasticity of unemployment duration to unemployment insurance benefits, the replacement rate of benefits, is an order of magnitude larger than in the data. We then develop a new framework that blends the very many desirable features of Hall with a standard discount factor and augments it with physical capital. I'll show you the such a model resolves the desirable features of Hall and is capable of reproducing business cycle patterns of a host of real and financial aggregates. In our view, the appeal of this mechanism is that it's grounded in what I'm going to argue is a long-standing theory of firm value dynamics that is really missing from existing search models and is at the heart of business cycle model of discounts. So our key takeaway is that Hall insights on the importance of discounts for business cycles survives when suitably amended, and we build on it as a key step towards a unified theory of real and financial business cycle. So what I'm going to show you is going to be a love letter really to Bob Hall's 2017 piece, but it's going to be a little bit of tough love. So let me start with the mechanism.
I don't know, you need a microphone.
Oh.
Either you have to stand
Oh, I'm
there or
sorry.
you take the microphone.
I'll stand there.
Okay.
So let me start with the mechanism of first generation search models, in particular its workings and failures. So in first generation search models, as I alluded, the volatility of unemployment is governed by differential productivity mechanism, in that the productivity of market time fluctuates in response to aggregate shocks, whereas the workers' flow value on non-market time B in terms of opportunity cost of posting vacancies are constant. And these are very common assumptions. To see what happens very simply to market tightness in response to aggregate productivity, just take a look at the pre-entry condition. That equates on the left side the cost of posting vacancy per full job to on the right side the marginal benefit in terms of surplus flows of doing so. Now, it's possible to show that this condition implies that the elasticity of market tightness with respect to aggregate productivity is completely determined by the so-called fundamental surplus. This difference in red between the value of market time A and the value of non-market time B, which is literally the value of moving a worker from home to market production. As you can see, a small fundamental surplus implies a large elasticity of market tightness, and so the job finding rate and unemployment rate to aggregate productivity. And that's the point made by Lundquist and Sargent. But by the very same logic, as you can see, this model tends to generate a reasonable response to aggregate productivity at the cost of an unreasonable, too large of a response to the replacement rate of benefits, to unemployment insurance policy in the words of Costin and Ryder. And that's because in absolute value, the two elasticity of market tightness to aggregate productivity and to unemployment insurance benefits move in lockstep. What happens once you go for the second generation's assumptions that Hall made a case for starting from the introduction in his 2017 piece, in that what happens once doubling the productivity of market production also doubles the productivity of home production and the cost of posting vacancies. It's immediate. If you take a look at the free entry condition, aggregate productivity simply cancels out. So the elasticity of market tightness with respect to aggregate productivity is identically zero. Put differently, a small fundamental surplus is irrelevant to generating unemployment fluctuations. All of the models in Lundquist and Sargent P suffer from these limitations. So let me take it for granted and move to what Hall proposed.
Some of those statements hold for a representative worker, but not a model with multiple types.
Absolutely.
That just,
Sargent Lucas, this was in Pisarelli school, there were a lot of papers, just to be clear. Sargent Lucas came around 15 years later, but this was known, I gave prominent sense of this stuff in.
Very good.
Very
good.
It has been a long time, but it's all about national bargaining, and then with this particular type only whole, but there's a lot of other ways having been explored. Yes.
So in this
There's a paper with Jordan and I, always 2015, we looked at 15 bargaining rules, and this whole has a specific structure, it's called counter-secure rents, but these are just ways. Yeah.
So there's something that Lundquist we correspond. Yeah.
but it's not a fight-word fight. You're gonna do something else, which is interesting.
Keep going.
Hopefully, you guys will talk.
I think this.
No. But let me just say one thing. So we deal with the homogeneous case, but if you were to go with models with heterogeneity and on the job search of the kind a la building on Robin 2011, I can imagine like this Robin, a similar argument works because it's critical the way you model the value of market time together with the cost of post and vacancies. But looking forward to more comments to come.
The value of market time doesn't matter at all in models of wage posting of job search because, basically you extract all the rents and, it's all about competition of employed workers.
In
the data, we know the job finding rate for employment, it doesn't really matter for wages. The whole view of our rates.
I just go ahead, so.
No.
I think
I can decide what to do. Looking for is a qualified statement, but I'll look forward to hear what we're doing differently. So let me, I'm taking you a little bit through the history of thoughts, because the exercise here will be to strip down what we know or may not know to what are the building blocks, the elemental building blocks of a model of financial and real business cycle. So let me go to Hall. As Hall himself described, the logic of what he was trying to formalize is that the flow benefits from a newly hired workers contains financial risk that is comparable to the risk in covered earnings. So the increase in the market discount applied to earnings similarly implies a higher discounting of the benefit flows to firms from adding any additional match. This mechanism operates along two margins. One is very intuitive. The discount factor margin that you would imagine that an increase in discounts amount to a decrease in the present value of profits from hiring workers, so firms end up hiring fewer of them. What is subtler is the wage margin that is equally, if not more powerful in the story. So in Hall, as you may recall, wages are determined according to an alternating offer wage bargaining protocol. Now I'm going to be working through this representation over and over throughout the talk. So it's easy to show that you can represent the EOB equilibrium as a set of outcomes that can be equivalently supported or implemented through a corresponding Nash bargaining equilibrium, but with time varying bargaining weights that are suitably chosen. I will go over this. It will turn out, I'll show you that this representation equilibrium is especially useful to understand how the AOB protocol is critical to the whole story. In particular, it implies something to us surprising at the beginning, that a workers' bargaining share is highly volatile over the cycles, in that a workers' bargaining weight effectively increases in bad times. That's why job creation contracts and increases in good time. That's why job creation is stimulated.
Can I make a clarifying comment?
Yes.
Just on the language. It's not your fault. It's Bubbles' fault.
It could be my fault too.
There's no difference between alternating offer bargaining and Nash bargaining. What matters is what is the consequence of a breakdown. Is the breakdown, I can have alternating offer bargaining. If the consequence of the breakdown is never see each other again, then you get back to history, this wage equation. If the consequence is that we skip a period of production and tomorrow we meet again, then you get bubbles.
Yeah, the real
it's not about alternating. It's just let's fix that language once and for all.
Okay.
It's about what's the trait, what's the threat of a delay.
I am going to go exactly through that, and I'm gonna you'll see what I'm gonna argue.
It's not axioms versus games. That's the point.
No. What we're going to say, actually, we find this representation useful to figure out what is going on and what's the issue, as I'm going to argue, in the asset pricing, what you hopefully will not see. What is the issue in the asset pricing properties that Hall's framework implies? So just to fix ideas, I wanted to show you in this figure that if you look at the dotted blue line that represents a worker bargaining share and a representative simulation of a recession in Hall against that solid red line, which is the unemployment rate in the data, as you can see, a worker bargaining share shoots up in bad times and decreases in good times. So it's highly volatile. But through such a mechanism, Hall is a success in that it reproduces almost to the dot the volatility of the job finding rate and unemployment. The issue here from our point of view is that this result is affected by two shortcomings that are central to the discount rate mechanism of the paper. And it all stands for the properties of this flexible, reduced form stochastic discount factor that hold positive. Very quickly, for those of you who may not remember, so hold pos is really a discount factor that implicitly, you have to work through this, builds on a class of pricing kernel that cannot reproduce fundamental properties of asset prices. And it relies on a counterfactual source of fluctuations in asset prices and accordingly in unemployment. So what Bob did, he posited a stochastic discount factor in which marginal utility at time t depends on the stated ST, which is a convex combination of aggregate productivity and market tightness that is governed by a stationary Markov chain. The appeal of this specification is obvious, clever, because it can recover the process for the STF, but for a simple approach that does not require a long time series of observations. But the catch is that by construction, such a discount factor features in the language of Alvarez and German Econometrica 2005 no permanent component, namely through the logic that is literally working through the argument about Alvarez and German's main result. In an economy like Hall, an infinite duration bond ends up being the asset with the highest expected one-period return. And therefore, by the no arbitrage logic, long-term bonds are the riskiest assets in Hall's economy, which is clearly counterfactual. The second point is a little more fundamental and a little more essential to the discount factor story. So most of the variation discount rates in Hall stands for variation in the mean, not in the dispersion of the stochastic discount factor. It's easy to see, if you browse through the tables in the paper, that that leads to an implausible movements or movement in the risk-free rate. It's an order of magnitude more volatile than the data. But that's apparent from the result that Hall himself report. An issue that to us is a little bit more troublesome is that almost all fluctuations in asset returns arise from fluctuations in the risk-free rate, not in the risk premium. And without this variation in the interest rate, unemployment, although employment is volatile, unemployment barely moves. And you can see very quickly in the data, the risk-free rate, as we all know, is low and stable. In Hall's model, the risk-free rate is high and highly volatile. In the data, the equity premium is high and volatile. In our models of discount, the equity premium is low and an order of magnitude less volatile in the data. In his model, it's magic, meaning the unemployment rate that the model spits out overlaps. I mean, it's really undistinguishable from unemployment in the data. But if you were to fit into the model a data consistent risk-free rate, you would see that unemployment barely moves. So to summarize, in the data, as we all know, the interest rate is low and stable, and the equity premium is large and volatile. The risk property of assets in Hall's economy exhibit exactly the opposite profile. So the task here is very unambitious. Working through this idea of discounts is powerful and novel to try to figure out if it all survives once you think of a standard stochastic discount factor, but an economy that has desirable risk properties.
So the goal here is not to basically undermine the argument, but to say, so if I want to understand fluctuation of employment, that should still be enough. It's the wrong reason. I don't care about how you compose risk premium and the interest rate. The question is that composition important to understand employment itself?
Well,
or is just to understand asset prices?
So the way that
So if I don't care about asset prices, I only care about unemployment, do I have to do this? I mean, that's important, right?
So the motivate, I think that the spirit of this exercise and the very many conversations we had, so his point is that if we all want to move towards understanding where movements in discount come from, and do they possess amplification and propagation properties, his story is a negative one. The answer through the homework that we went through is that no, there's no way, unless you have crazy movement in interest rate, the movement in asset prices can really lead to movement in unemployment.
So this one help us understand where these shocks are coming from.
Or whether you can have asset prices move unemployment. Because in his world, It's just movement in the risk-free
We
rates.
classify as one, but all the other way around, that's a little bit of, you know.
It's a bit of a-
It's a, you know, that's your view,
If you're saying that you have interest rates going 0 to 15, 0 to 15, 0 to 15, I want to have that is the primitive mechanism. We haven't seen that in 200 years or any country in any
all the
time.
models, right, have a lot of kind of function, I mean, the model is a model, so if you want to.
That's like
No, it is an
So
easy
the
story.
That's like putting productivity
So,
factor
do you have
in this type of model,
do you have an
nothing to do with
explanation?
the data, it's just uninteresting.
Do you have an explanation for the discount factor?
Yeah, let her do her thing.
I mean, that was the question.
Yes,
Yeah.
sorry,
So
Giuseppe.
you're gonna have. to
Basically,
finish,
it's
so
a two-way conversation or three-way
we need
conversation.
to short, so you will understand.
The question
What's
is
the
exactly,
definition?
it's a very humble exercise of figuring out, going back to impulse and propagation. What is a reasonable impulse and does it possess sufficient propagation power to get to move unemployment? So what, Cynthia?
I think also to answer the question about, I think, is it on? Okay, also to answer the question, I think the whole mechanism is gonna give you weird unemployment fluctuations, you allow for there to be heterogeneity in the labor market. So if you wanted there to be more unemployment volatility for the gamma type, like in Pluto's paper, the whole mechanism would tell you that the alpha type is gonna be having high volatility. And so you need to correct this issue with the asset pricing in order for the right durability type of labor.
That's a good point. So we have worked through this. So we have worked through a version with multiple skills and we see something along the line what you're saying, Cynthia. But so to speak, we want to strip it down to basics to figure out whether there's something to the story. So the baseline model that we start from is just embedding Hall in general equilibrium with an endogenous stochastic discount factor. I'll give you the cover to manage with it. So we embed Hall in general equilibrium with FCNC type of preferences. Why this kind of preferences? Because they generate a discount factor in line with what we think is the current benchmark in the finance literature. You see that we get right off the bat a model that solves quickly the two issues that we've gone so far through. Namely, it reproduces asset pricing well, retaining the ability to replicate the volatility of unemployment into data that Hall matches to the dot. So how do we proceed? That's the environment. So we have met Hall, as I said, with absence in preferences, allowing for two sources of shocks. Discount factor shocks and higher productivity shocks along the line of Albuquerque et al. And Shofai, Song, and Yaron. That's the golden standard as of now. And what I mean is that we allow for shocks to the growth rate of a family discount factor, which follows an Yaron process. The economy consists of large Lucas type of families. And we also allow for shocks, log productivity growth, that contains a predictable long-run risk component, also governed by an Erewhon process. As in Hall, all shocks to discounted productivity are independent. How do we parameterize such baseline? Well, we choose parameters for absence preferences, for the process for the growth rate of a family discount factor, for log productivity growth, and for the process of its predictable long-run risk component, so as to match a number of moments. The mean volatility, the risk-free rate, this is really standard fare. The maximum Sharpe ratio, defined as the ratio of the conditional mean to the conditional standard deviation of the excess return, and the autocorrelation variable productivity. Let me turn to the labor market.
A quick question
Yes.
about the discount factor. So in G search models, discount factors do a funny thing, which is that's what my experience. So when discount factor goes up, firms want to hire more, but consumers consume less.
Yeah.
And so you have this negative correlation between investment and consumption if you take up hiring and investment. So to me, so people used it in these mortgage models, but there was no,
It's a bit weird, yes.
So
I understand what you're saying. We have other issues. Our point is that in addition, yeah.
it's a very interesting, very trying, but it's just about.
Okay.
Okay.
So I just wanted to, these slides are mirroring each other. This is standard, so to speak, finance set of the financial side of the economy. I would argue there's a standard setup of the economy, the labor market side of the real economy. From post-vacancy, they match with workers who immediately start working. And if they separate, they must wait out one period before looking again for job opportunities. Foreign worker meetings are determined by Cobb-Douglas matching function. The law of motion employed unemployment is standard to state models. That's the aggregate resource constraint. What's important here is that we follow Hall's lead, and all flows, payer flows, are scaled by area productivity. Market production, and vacancy posting costs, and the hiring costs. The labor market conditions are the one you want to imagine, very standard. Let me go to what's important here, following up on Guido's comment, which is how is the present value of wages determined for a match firm and worker pair? For those of you who are not familiar with it, so upon matching, randomly the worker and the firm are selected to make an offer. Then they alternate making offers in real time until either an offer accepted or bargaining breaks down for endogenous or exogenous reason. It breaks down with probability delta. A worker's present value wage offer, subject to the constraint that a worker has to prefer becoming employed at that offer than being unemployed, has to make a firm indifferent between accepting it and rejecting it. When rejecting, the firm has a further decision as to whether abandon negotiations or keep on bargaining if bargaining does not exogenously break down, in which case the firm has to pay disabling cost to go and formulate an offer next period. It's very symmetric on the firm's side. The firm's offer of present value of wages is subject to the constraint that the firm has to make non-negative profits if the offer is accepted, and has to make an equilibrium worker indifferent between accepting it and rejecting it. If the worker does not reject it, does not abandon negotiation, bargaining does not break down, in the period, the worker gets the value of unemployment. This is going to be key to the entire story. I'm going to build up in a couple of slides. This model works like a charm, meaning it matches asset prices well, including the excess return, mean standard deviation, the log dividend price ratio, long and short interest rate yields, labor market statistics well. In fact, all moments that you could possibly imagine well.
What is the set of assets in the model?
You're pricing the consumption claim. We're pricing the consumption claim, and the interest rate is the rate on an asset that plays one in all states of the world tomorrow.
Then there is a cycle with consumption investment, the consumption and output. So they're not there was a bit fast.
It was a bit fast. We look at our productivity. Now,
so kind of standard business cycle model.
Yeah. But so let me tell you, the segue that Guido gave me is so to speak. I'm gonna zoom in onto something that we're very unhappy about, nonetheless, and that motivates to us one more wrinkle. So the first thing that you need to fix is having an economy that is real financial properties. You see what the second wrinkle, there's on the real side of it, something is still amiss. So very simply put, it's easy to show that there exists an affine relationship, log affine relationship in all these kind of discount factor models, Hall and our baseline, between the job finding rate of a worker bargaining share, and scale match surplus. It's easy to show that using this relationship, you can exactly decompose the source of fluctuations in the job finding rate into the fluctuations that arise from the fluctuations in a worker bargaining share or surplus share and in scale match surplus. This picture tells it all. Our baseline model as all works because a worker's bargaining share, look at the red line, is highly volatile. It increases from about 35% at the onset of a recession to about 55% when job finding rate bottoms out. So firms are reluctant to hire workers in recession because workers demand large surplus shares. And my argument is going to be in this slide and the next, that this is the key to the mechanism. And this mechanism, as Giuseppe was saying, why do we care about this? Because I'm going to show you that along dimensions of the data that we care about, which is the cyclicality of wages and the response to employment insurance policy, a model like this without an additional ingredient is always going to fail. And I'm going to build the reasoning for why you really need to get outside of the mold of these kind of models. Very simply put, to get insight for why these bargaining share movements are key to the story, you can just compare the cost of delay for a firm and a worker. If you look at this difference, well, very intuitively, the cost of delay for a firm is just the cost of haggling with a worker. But for a worker, the cost of delay, well, is simply the cost of rejecting an offer, bargaining tomorrow, and the value, the expected value of doing so, well, is the value of meeting tomorrow firm, getting matched getting the share gamma t plus 1 or tomorrow surplus bt plus 1. It turns out that this difference is highly procyclical because worker cost of delay is much lower in recession relative to the cost of firms. How can you possibly see that?
Something about the environment. What if there's alternating offer bargaining? After somebody says no,
yeah.
What happens? You make an offer, I say no, then?
You go back and search again.
You go back. You can quit bargaining.
Is that
or
what-
you
sorry.
Oh, no, you have the option to stay.
No, you have to always.
You have the option to stay.
Sorry, I shouldn't do this. If you quit, meaning that you decide to abandon negotiations, and you're a worker or a firm.
It doesn't matter.
So either way, so you can always choose to abandon negotiation and leave the bargain,
Which you'll never do.
which you'll never do.
Yes.
You may be forced to abandon it because the opportunity to bargain expires, or you keep bargaining.
And the problem arises no matter what delta is.
That's the whole point.
That's the whole point.
That's the whole point.
Because the discussion, sorry, this is not to be, the discussion in the paper is in Hall, the discussion is how to align the probability that a worker or the firm is selected to make an offer and aligning with the elasticity of the matching function with respect to the measure of unemployed job seekers. The overlooked aspect of it all is the probability of exogenous breakdown. It's key to the whole story. And I wanted to show you why. It's key to the story because if you work through the difference, I'm going to just assume from now on that the elasticity of the matching function with respect to the measure of unemployed job seekers is 1/2, and like Hall is equal to the probability that a worker is selected to make the first offer. If you work through the difference between the efficient share that worker bargaining shares, you see that this difference is really dependent on the present value of this relative cost of delay that I just introduced. This condition shows you why the probability of exogenous breakdown in bargaining is essential to the story. Because when the probability is 1 and the alternating offer weight bargaining gain reduces to an ultimatum gain or take it or leave it offers, you see this right-hand side is identically 0. The worker's bargaining weight equals the elasticity of the matching function with respect to you. You have, there was this condition of for efficiency, in particular, the bargaining weight of a worker is constant over time. But as the probability of breakdown decreases, the right-hand side becomes positive, and what happens is that when a recession hits, as Giuseppe was saying, we know that discount rates decrease, a discount rate-driven recession, but the cost of delay greatly increases. Why? Because all future discount rates, the finding rate, and match surplus greatly decrease. And as delta, the probability of exogenous breakdown becomes smaller and smaller, you can see in this present value formula, future terms are less heavily discounted, and so workers' bargaining rate becomes more and more sensitive to fluctuations in discount rates.
How do I interpret delta? It's not, it's not the.
One slide, give me one slide.
The surplus.
Give me one slide because it was the question we asked ourselves.
And somehow we don't get to divide it anymore.
Go ahead. I'll go first.
So it's perfect segue to what I'm going to show you guys. We had, how do you possibly interpret this delta? But let me say that this, if we weren't picky, this mechanism does well along this standard finding rate and unemployment volatility statistics. But our issue is, what is this bargaining about after all? And what does it, the way that if you read the Hall's paper, the motivation is that you somehow need sticky wages. Somewhat sticky wages to get the right movement in quantity. It's way more than that. So the 3 implications of this model that are to us unappealing is the production efficiency that it gives rise to, in that this model generates volatility and unemployment by relying on a very specific failure of individual profit maximization. It implies wages that are much less cyclical than in the day, in fact, counter-cyclical, and is unable to reproduce the observed sensitivity of unemployment duration to unemployment insurance benefit replacement rates. So here, I'm going to be very brief because I think we touched upon a lot of this. So it holds this type of result. I know that's what Guido already had in mind, holds here in the sense that when the probability that a worker is selected to make an offer equals the elasticity of the matching function with respect to the measure of unemployed job seekers, then you can show that if you index the allocation in a sequence of bargaining the game, that is probability of exogenous breakdown, well, you get efficiency as the probability of breakdown gets closer and closer to 1. So delta and pi are critical for efficiency. And what I mean by that is that for us, the delta is problematic because no direct evidence can possibly exist about its value. It only disciplines of equilibrium path behavior. And it's hard to justify to us inefficiency because it's not due to any complex external effect. It's just firms failing to choose the bargaining protocol that will individually maximize profits. So the point what I want to make is that this is really an economy that's highly production inefficient. In the sense that if you were to allow, for, like in a directed search framework, if you were to allow firms to choose not just how many vacancies to post, but also the bargaining protocol, they will never choose the AOB protocol with the delta that is typically selected. And
I know what they choose. I
The
think they'll
efficient
leave
one.
it off.
Yes.
So, yeah.
With the.
Yeah.
No, no
So
bargaining whatsoever.
With the wholesale.
So in this case, it's not an efficiency, I mean, congestion externality, if you wish, a failure of coordination market-wise. Here's a failure of individual bargaining. The tension, if you wish, between ex post and ex ante efficiency. The profit left on the table are roughly 6%. The second issue is the counterfactual cyclicality of wages. Very briefly, I think Mariana is not here. Well, in search models, the labor input is durable, so a natural notion of wage is the user cost of labor in analogy with physical capital. The user cost of labor in this model is the shadow value that makes a firm indifferent between hire a worker today that survives tomorrow with, in this case, probably 1 minus sigma, we don't have an endogenous separation, versus hiring a worker tomorrow in the event that is relevant should the worker quit at the present value of wages prevailing then. If you measure the degree of cyclicality of wages in the data by the semi-elasticity of the user cost to the unemployment rate, it's about 5%. So 1 percentage point increase in unemployment rate leads to more than 5% decrease in the user cost of labor. A model like Hall and ours doesn't do a lot better, our baseline, implies essentially a cyclical wages. And the reason, simply put, has nothing to do, we were confused with the financial side of the economy. How do you dislike risk intratemporally versus intertemporally? Nothing to do with this. We tried all preferences, finance consistent preferences under the sun. It's always got to do that the bargaining share workers is so volatile that saying bad times, the bargaining share shoots so much that wages effectively increase. These are the impulse response functions I'm going to skip. The third unappealing feature to us, the death knell to the homework that we set ourselves to solve, is how extreme the cost and rider issue becomes. Namely, in their words, these smaller generate volatile unemployment tend to generate very large responses to unemployment insurance policy. Here, it's crazy. If you were to use it as metric for such a response, the average elasticity of unemployment duration to a 1 percentage point increase in the replacement rate of benefits, you would find that the elasticity in the model is 22 times larger than the midpoint of the elasticity estimated in the data by Gannon and originally Schmider and von Vactor. So to us, we need something else. So here's the wrinkle. Of course, there are very many attractive features of Hall. You may or may not like the AOB protocol. I mean, we think that there's something appealing about having something a little bit more micro-founded. Extreme parameters are certainly more interpretable than reduced form Nash. But the game we're going to play, going back to some of the initial question, we're going to play a different game in terms of how we engineer the source of volatility of unemployment. The baseline model, Hall, and variance of his model generates it from a volatile bargaining share of relatively stable match surplus. We're going to go for the opposite. We're going to generate it from a stable worker bargaining share of very volatile match surplus. And we're going to do it by reintroducing physical capital accumulation. Why? Because if you think about a theory of discount, what is a theory about risky surplus flow? What's the term value? Well, it's going to come from capital, tangible and or intangible. Here's the logic. I saw it, thank you. Since investment in capital is highly volatile over the cycle, a natural candidate source of fluctuations in match surplus that can greatly amplify volatilities. Go back to Hoffman, a paper he wrote in red in the 90s. It's introducing physical capital accumulation. But we all know that simply embedding a search model in a standard growth model, one sector, multi-sector, is not going to work. So what are we going to do? We allow for both intangible and intangible, namely the non-relevant case that McGrath and Prescott, Eberly, Cruzan and Eberly, many others popularized, where the idea is that each unit of capital can be used alternatively to produce consumption of either type of investment goods at the same time, meaning the two uses of capital are non-competing, or the standard case of rival intangible capital. You can only use capital for consumption good production or investment good production. It does matter. There's a huge debate, and I'm sure you know, there's a huge debate in the business cycle literature dating back 30 years ago. It does amplify the impact of a discount rate shock on the employment volatility. But what's key here is the non-rivalry of labor and the consumption investment good production. That's what's key. The labor has to be producing both consumption and investment good, because intuitively you want labor exposed to the volatility in the shadow value of capital, which in fact is highly volatile in response to discount factor shock. That's intuition. The mechanics of it all is that we want the shadow value of employment, which is formally speaking match surplus, to be determined by a dynamic system that has a large loading on the long-lived root that capital introduces, so as to remedy the problem that we know that search models are effectively static. So why we start with intangible capital? Well, because there's a long tradition in macro, going back to Jovanovic, Nelson Winter, Hovenham, and Rogerson, about firm-specific learning by doing, whereby firms evolve by accumulating physical and organizational capital as workers produce output and long-lasting knowledge. That's the first initial idea of non-rivalry in the use of capital. For us, it's a natural benchmark because if following Cruzan, Eberly, Papanikolaou, Einsfeld, and Papanikolaou, the finance view, modern finance view, is that intangible capital is necessary to account for movement in stock prices. So we want a story that hangs together.
Is it necessary, like habit formation, other stories?
I'll tell you. Yeah, not habit. I'll tell you what the technological feature that is critical, our understanding. So the setup, I want to really take you to how we thought about it. It was almost really engineering an environment whereby the bargaining solution could really be copy-pasted from the baseline model. So we introduced this fiction of recruitment agencies that bargain with workers of allowable firms, because we're going to have multi-worker firms with very rich technology. The bargaining gets very intractable very quickly. So these agencies pay capacity to recruit workers. They bargain with them over wages the way we've seen before. They turn around and they rent worker services to firm at a competitive price, PT per worker. Otherwise, for all practical purposes, they're identical to the firms that I showed you so far. The interesting bit is the production of final goods. So we have these large multi-worker firms that Cobb Douglas output technology in 3 inputs. For today, I'm going to take physical capital as fixed for simplicity. So we have decreasing returns and meaningful notional firm size. So in 3 inputs, physical, organizational capital, and labor. Organizational capital evolves a la Cruzan, Eberly, McGrath and Prescott, etc. The problem is simply to maximize profits each period by renting worker labor services. The condition for labor market equilibrium are exactly as before once you replace salary productivity with the flow revenue of an agency. Let me tell you how it all works. Really, the best intuition to us was gained by working through the planning problem. So given the technology of output and organizational intangible, capital production, the planner chooses each period consumption, market tightness, employment, and next period or end of period capital so as to maximize the present value of consumption subject to the aggregate resource constraint, the low motion of employment, the low motion organizational capital. Here's the critical thing. The 2 objects of interest are the scale multiplier in UT and the low motion of employment, and the scale multiplier, the shadow value in organizational capital, which is the value of amount in the capital by 1 unit. Look at what happens. If you look at what determines the shadow value of employment, which is match surplus in this search model, and the shadow value of capital, they are jointly determined by a dynamical system where the game is, as we talked about, to expose labor and match surplus to the volatility of physical capital. So you need a positive loading terms on the shadow value of capital. How do you get that? Well, you need the marginal product of labor in terms of investment in group production to be positive. Put differently, labor has to contribute to the creation of capital in the economy. It has to be, in McGrath and Prescott, non-rival. If labor was flexible, technologically flexible in use, you would have an attenuation effect already. The standard growth model does not work once you introduce restriction, because when labor and capital are flexible, that's a typical rival labor case, intangible physical capital case. That's what took us a long time to realize. The loading terms is not zero, but the shadow value of capital is constant. And the model, this is Tallarini separation of the financial and the real side of the economy. You will never get any amplification in terms of unemployment volatility. So to put differently, you need an ingredient that locks in labor and in capital production terms. Without it, without it, even if capital introduces a potentially very large root in the dynamic system that describe the evolution of the economy over time in response to aggregate shocks, fancy aggregate shocks, you will get nothing. Very simply, in terms of the parameterization, we follow the literature in intangible, and we assume that the GDP in NEPA is this measure by the amount of the labor income share that derives from the production of capital, but the parameter is very standard what we do. We use this condition that constant return to scale property value of production, the intangible share of capital, the NEPA labor share, and the balanced growth path of the economy that implies definite shares for all inputs. This is how the model works. As you can see now, the worker bargaining share is much less volatile, but match surplus is highly volatile. How does this model work? Asset prices, labor market statistics are matched very well. And here, I'm gonna end the way I began. How much time do I have, Giuseppe?
3.
Oh, 4 minutes.
4.
Fantastic. Okay. I'm gonna end the way I began. This model fits very well the cyclicality of wages and the Costin and Ryder puzzle. So I have the time to go over all of this. How can this model account for the data? Here's a trade-off. If you were not to have intangible capital in the model and allow for severe inefficiency, that's the game that Hall played, you get easily unemployment as volatile in the data. But you get wages. These models, a la Hall, get too sticky wages, so you will never match Kudliak-Knoll volatility, cyclicality of wages, and you will have crazy unemployment duration. And why is it so? Because the logic of the fundamental surplus of Lundquist and Sargent does not work in unemployment space, but it works in unemployment duration response to unemployment benefit space. To put differently, you need not a small, but a large fundamental surplus to be able to solve the Costin and Ryder puzzle. So you can recycle the logic because it's true. When the probability of resultant breakdown is high, the fundamental surplus is large, and the elasticity of market tightness to the replacement rate of unemployment insurance benefit is low. Voila. So the byproduct, or if you wish, a validation, logically speaking, of the exercise is that once you put together a model with organizational capital and what we think is a plausible bargaining duration, in our preferred calibration is about 4 months, then you get it all. You get unemployment that is as volatile as in the data, wages that display the same cyclicalities in the data, and an unemployment duration that is as elastic to be as in the data. So the success of our model in our review, this accounts for key features of labor market and asset prices. If you were to decompose, where does it all come from? Well, in impulse response function space, because the steady state calculations are now very informative, you see that I'm going to show you what happens in the response to discount factor shock, but the response to a long run risk shock is identical. Now we get what we see in the data. When a shock hits and unemployment increases, the user cost of labor decreases, not increases. And that's due to the fact that a worker bargaining weight increases little, but match surplus dramatically declines. A long-run risk shock will give you exactly the same. So what's the mechanism of the model? To us, very intuitive. So the model implies, if you go back to the decomposition that I showed you a few slides ago, so this model gives rise to very modest inefficiency. Firms lose less than 1% of profits, even in a severe recession that shoots unemployment up to the 90th percentile of the observed unemployment rate in post-war data. And the variation in surplus flow accounts for about 50% of the overall fluctuation in the job finding rate and the unemployment rate. To conclude, existing second generation search models based on discount rate fluctuations, in our view, fail on multiple fronts. As a logical exercise to understand what is the source of the fluctuations that we see, what kind of co-movements can be generated if we want to move past the Talarini separation results or a real financial side of the economy, well, you need realistic discounts, but they are necessary, not sufficient to remedy just the asset price failure and the failure of movement in unemployment that you would otherwise get. We propose a new framework that simply extends and love for Hall, his original idea, is consistent with the measures of cyclicality of wages, the response of unemployment duration to unemployment insurance policy. Customer rider has been a puzzle looming out there for a while. And it matches a host of real and financial business cycle patterns. Going back to Giuseppe, I didn't show you all of the details. Depending on how you model the imperfect transferability of labor and capital across the investment and consumption goods sector, you get the right movement in consumption and investment in the aggregate as well. And we hope it's a first step towards a unified